Okay. Yes. Share. Yes. Okay. Audio is cool. Alright, just gonna get started right away. Hello everyone. Yeah. So we did well around 20 yesterday and so on. Today let's just continue that. So I know how to solve this one. This one we looked at. This one we can do. How's G? Small fan, yeah. I am a small fan of myself too. The links are still not working, by the way. It doesn't make any sense. They said 24 hours ago. I don't know what's up with that, but whatever. Okay. That's kind of hard. Let's see what it looks like. They're in locations on a snowy mountain range. Yeah, check chat. Just not that often, I guess. I mean, usually between problems. Sometimes in between. Sometimes like throughout. Seems kind of painful. Let's if it's 3300, let's not do it. What's E for this one? Okay, we can do E. Yeah, going for around the same time. We'll try to. We should be able to. This one I've looked at briefly, but I haven't tried to solve it, so we can do it. Which country developed airlines? They're in cities. Okay. So we need the cost. Yeah. Cost of any route that consists of several consequent flights. Seek one of the costs of the most expensive of them. Right, okay. So, so this is strange. Are you directed or not? Bidirectional, okay. So, so to get max, so to get min-max cost, how do we do that again? We need some sort of spanning tree, right? We need some sort of spanning tree. We need some sort of spanning tree, right? That's what we're doing. What do we need? Okay, right. So, yeah, we're doing MST, right? Like, that's what we need to do. We need to do MST. Because, like, if we have an edge such that you could already reach here using smaller or equal things, then this edge is completely useless. Otherwise, if this edge is the smallest thing to connect these two components, then it is necessary. Therefore, the MST gives us the answer. So the cost of any S8 Airlines flight is the distance on the MST. And we're looking for the MST of the S8 Airlines flights, which is a large graph. So how do we do that? How do we find the anti-MST given this weird structure? That is our plan. I don't know if this has strong topics. I mean, depends on the problem. Usually not. Usually these problems are just hard because they're hard, not because of topics. This one might be. I mean, so far there's MST involved in it. Okay, so I mean, we want the S8 MST, right? So let's consider then the components of the tree. Let's consider then what? So put all the nodes into their own component. Then take the smallest edge of Berleflot. Stupidest name ever, right? Now try and merge the two components, right? And what we're going to do is literally iterate through all the edges of that. And what that will accomplish is what we can do is literally iterate through all the edges of this. Yeah, there's a weird dissonance between like inventing problems and solving them, because like I don't know, you have infinite time to solve a problem, like when you're inventing it, but in contest you only have like 2 hours, less than that, maybe an hour to solve this one. Like given infinite time, you can get a lot more done. I think that's why even like masters and stuff can come up with 3500s, and you have people to discuss it with. You have a lot of minds working on the same thing. This problem seems easy, which is why I'm scared of it. Um, um, Seems easy, but it looks annoying, I guess. Like we take these anti-components, right? When we get an edge of weight 7, consider all the components of size of edges up to 6, right? Anything in these two components can thus be merged. Every time we fail an edge, it must exist in Barrelflow, which means it costs us an input. So this actually shouldn't be that bad. It should not be that bad. So we need some DSU stuff going on. When we DSU merge, yeah, okay, I think we can do this. It's just gonna be weird. Weird and, oh my god, I have 400 lines from the previous problem. Awesome. I love having a 150 line main function. Just so much code, man. Okay, we don't need mod op anymore. Yeah, I'm reading chat. I'm in CS in college. Yeah. Okay, so does this problem have a large time limit? Yeah, it does. Okay, we can do this. So we need like 2 simultaneous DSUs, right? So we have a first DSU that maintains the Berlaflot ones, and then we have a second DSU that maintains the S8 ones, right? And then within that, okay, this problem is actually not that bad. I should have looked at it in contest because it was getting solved. This contest I did pretty bad in. I couldn't solve D, but yeah. I mean, I know how to do it now, but that was a shame before. So this one is, we still think about how to code this. Like I think the idea is really not that bad. Just need to do it efficiently. Like every time two components are not merged together, we spend an edge, right? So in theory, for the first DSU, we can just do light work. Yeah. So for the first DSU, we literally just go through each one. Every time we do the second one, we reset the set. Yeah. Okay. All right. This is stupid. And we have to do this problem because pain. Well, we have a solve. It's better than yesterday. Okay, so I'm not doing these rounds anymore though. These Moscow OIs things. It's freaking painful. Test cases too. So DSU. Can we do this smartly? Let's not. Let's not. Gym is meant for ICPC style stuff. Like, most of the contest is like ICPC regionals and stuff like that. If you're just trying to get good at programming, then just stick with the problem set. It's good enough. I mean, if you're training specifically for ICPC, yeah, it makes sense to do that though. Okay, so struct DSU2. Okay, so I need to be a little careful. Just a tiny bit careful. Well, no, right? Well, yes. Oh wait, no, this component hasn't been merged yet. Okay, yeah, so this component will not have been merged. And thus, this is fine. We don't need sets. We need a set for the second. We don't need a set for the first. How do we code this? So for this value, God, it's such an unpleasant problem, man. Why do they do this? Why do they set these problems? Like who'd voluntarily want to put this on a contest? So we literally, for each thing in the original set here, okay, if we do this smartly, right? If we do this intelligently, every time we hit a merge, right? Is DSU a beginner's topic? I don't know. It's not that complicated. Like the code is very simple. The proof is not, but the code is pretty simple. So it could be considered a beginner's topic. Yeah, it's just like built on top of graphs and stuff. Structured training. I mean, I don't generally go for that idea, but if you're doing a thing where topics are very important, then maybe so. In limited time, I suppose, under those constraints, it could work. Okay, so we do the DSU magic, right? We do the DSU magic. And what happens here is that we need to do the thing with the smaller set, right? And then for everything in this set, yeah. Okay. So that is actually going to be based on sizes, right? Yeah. So for each thing in A, for comp comp A, set LL S is equal to D2 dot comps D2 dot comp. Why do you compile, right? Okay, now comp is equal to D2 dot marks comp. No. Wait. Okay. Vector pair L set LL v dot push back S comp D2 dot comps comp. Okay. Now for auto comp S comps A comp is equal to D2 dot marks comp. For LO comp 2 comps B why? You work fine, right? Do you not work fine? You're gonna crash on me? Frickin' terminal? Oh yeah, I just said like DSU is it's a pretty like simple topic, so it could be considered that. I don't know like at what point it appears, but it cannot decompose non-array, non-class type. Oh, because I'm an idiot. Yes. You gonna work now? Thank you. Okay, so comp is equal to D2 dot marks comp. No. And 42. For LLX S for LLY wait, no, we need to no, we do not. D2 comps comp 2 comp is D2 dot marks comp. If comp is equal to D2 dot marks comp 2, go to end break. Vector array L3 E G B. Okay. Insert norm XY. Stop it. GV. Greatest product of x terms with the condition. Think about 2 and then plot it and then realize that it's best for them to be closest. And then generalize that to all of them. That's pretty much it. If they can be real, then yeah, you just do y over x, but otherwise you want them to be as close as possible. But like the way to see that is to like do it with 2 and then hope it generalizes, and then it does, so it's fine. If comp is d2.marks comp2, go to end break. D2.merge. If d2.merge xy, gv dot push back xyw. Bool merge. Go to end. What? Why? D2.comps. Oh, wait, marks. What am I doing? Okay. Now for lx comps a, rc.insert d2.marks x, comps b.insert d2.marks x. Okay, that's the code. Now this should be simple. For lx comps a, comps b.insert x. This doesn't actually need to be a set. Yeah, this doesn't need to be a set. VL. Okay. Still compile? Okay. Now, for auto z, x, y, ev, d.merge x, y, z. Damn. Okay. Why? Because we're not editing it at all. Do not push back. No, that's not correct. That's not correct at all. Damn. That video is not that good, so I took it down. If you want the insight in that video, I can explain it later on Discord, though. That binary search one, I mean. Okay. Why now? PR. Wait, oh, that's why. I can just do this, right? Okay. No. Not ban.count. That would matter. Okay, yeah. Cool. Wait, there should not be. Oh, yeah, there should be. Okay, yes. Okay, we're gonna hope this is correct, and then we're going to stick in LCA. Okay, we don't need this at all. Cost b 0 is equal to w. Min. Put that first. No, it should be max. Max, yeah. How's this work? Lift VI. Right, you're gonna go here. W equals max W cost V0. W equals max W cost B0. Turn W. Why? Because I didn't do the freaking thing. Yeah. It is good the VS Code tells me this. Cool. Okay. Yeah, I guess it works. Works on samples. And therefore it works always. I mean, I don't know. Scene to end, vector array, LO3, EV, band dot, okay, let's make sure we're resetting things. Band dot clear, GV dot clear, yeah. Vector PL IV, EV dot pushback ZXY, sort, band dot insert, norm P, band dot insert, norm P, yeah. D dot init N, D2 dot init N, EV, D dot merge XYZ, LCA lift LC, LC dot init N, LC dot edge, LC dot init lift, yeah. Check the LCA part. I mean, W is 0, right? W is max, W cost. Cost VI is 0, cost VI is max, cost VI minus 1. Yeah. Yeah, then we pay you because we must. All right. Then we pay you because we must. Then we pay you because we must. Then we pay you because you're gonna be, yeah. Okay, sure. Cut now. Don't need this. Norm P, yeah. So this one's simple. Let me just do that. This one's a bit more complicated. So we save the sets so that we don't spend that much. Then for each thing in this set, if you're already equal to this component, great. If comp is not equal to d2.marks comp2, comp is not equal to d2.marks comp2, sure. LXS for LLY, yeah. For each thing in that, comp is d2.marks comp. If you're already that, go to end. Otherwise, merge X and Y. Then set LRC, do that. Comps B dot insert d2.marks X. Okay. Sure, makes sense. This could TLE. I hope not, because it's n log n. I think it's n log n. Pretty sure it's n log n. Ugh. Great. Why are you wrong answering? That doesn't make much sense. Scene to end m vector array lo3 ev band.clear gb.clear vector pl iv I is 0 up to m. ev.pushback zxy. Yeah. Sort by weight. You should be you're non-negative. Yeah. Band.insert norm pxy. Oh, I didn't clear band. No, I did. Yeah, we clear band, clear gv. Those are the only two global things, really. Well, d. Yeah, you get reset. You get reset, you get reset. Okay, yeah. iv.pushback xy. Sort ev.begin, ev.end. For each thing, do the merge. Auto xy iv. Then just do the path. Right, so then in merge, if you're already the same, which you shouldn't be. No, you might be, yeah. If you're already the same, return. Sizes marks A is greater than sizes marks B, swap A, B, yeah. A is the smaller one. So for each thing, archive you. For auto comp S in V. What? Comp is d2.marks comp. Comp is d2.marks comp. For each comp 2 in comps B, comp is d2.marks comp, right? Because you could have changed. No, you wouldn't have changed, but whatever. All right, now for each thing in this, if comp is not equal to d2.marks comp 2 already, right? If we're not already equal, which, yeah, we might be. For each thing in S, for each thing in the comps, if you're already equal, break. You shouldn't actually need that, right? Because as soon as we do a single merge, yeah, we shouldn't need this. It doesn't matter, but okay, so for each y in D2, so these are the nodes themselves, which means this should be fine. If not, band.count norm pxy. and we merge you with D2. And if this merge succeeds, then add you here and then be done. Right, and then for each thing in comps B, add you to RC. D2.marks X. Comps B is RC. LX comps A, comps B dot insert D2.marks X. It's like there's nothing to test here. I mean, okay, fine. Are there multi-edges? Yeah, no. It's possible to get from any stage to any other. You work, right? What am I printing? There's no edge 3, 5. So you get merged with a 6. I don't know. Let's try the old multi-test trick. Yeah, okay. 3, 7, 9. So you can get merged with 9. That shouldn't change anything, right? Does it? Maybe. Oh, wait, no, it would. It's in the order of the input, right? Um, no, we don't need this. Vector, vector. Dist xy is equal to dist yx. Dist 2ij. Damn, okay. So we need a larger case, huh? Okay, we don't need freaking 100. Yeah, 10, 30. And it's just too high. Okay. Oh yeah, the freaking task. Yeah. I'm always going to forget that. Well, I never went for Sublime. I just didn't try it. No particular reason, I suppose. Wait, no, res is too low. Wait, what? Wait, okay, that makes no sense. This is like absurd. Can we please get a smaller case? Yeah, 7, 15. What? Where the hell is my 31? Come on. How hard is it to... Okay. What is it? MTT. I forgot it's MT, not MTT. Let's get a seed that works. Please, for the love of Christ. Why? Why can't I get a case? You gotta be kidding me, dude. Oh, wait. Okay. This is fine. I'm high. Okay, well, this one's simple. Oh, that's why. Um, I'm sorry, what? Oh, wait, no, that's fine. Yeah, that's fine. Okay, so I mean, you shouldn't be all zeros. That's somehow wrong. Somehow very wrong. We're missing an edge. How are we missing an edge? Okay, that's good. Yeah, we're guaranteed that we can do the thing, right? Yeah, I mean, for 7, we have 21 possible choices. If you were bad, you wouldn't count. But I mean, we know that there are anti-components. Right, because if there weren't anti-components, then yeah, this 2 would be garbage. Yeah. So we know that there are anti-components, so there's a bug somewhere here, right? Two, 4, 27. We're missing anything involving 7, right? No. What? 2, 4, 2, 6, 5, 3, 5, 4. We don't have any 0. That's what we're missing. But we have edges like 0, 5, right? So what's up with that? Comps A. One. So comps, you should just have 0, right? for LX comps B PRX D2 dot comps D2X. What? Oh my god. 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 That's so dumb. But that's not the only bug apparently. Why are you not the only bug? Well, it actually doesn't change anything. Why does that not change anything? Okay, PR A B comps B comps A. I'm sorry, what? Oh my god. This is freaking DSU. That's why. Okay. Let's try it again. I hate my DSU. I need to fix it. That's annoying. Running answer in test 1. Why? Oh, because I didn't. Because I'm an idiot. Because I didn't read the freaking input. That's why. Yeah, okay. Okay, well, let's see. Ugh. Good. Okay. That was a thing. 3,200. Nice. Okay. Chat. Hello. First problem down. That was only an hour. That's pretty good. Although stupid bugs. I need to be more careful with DSU because there's no reason to not have these lines A equals marks A and B equals marks B, but like sometimes with modification, like sometimes with DSU modification, you have to be careful with that. So I tend to be careful and just not have it on by default, but then I just got screwed by not having it on by default. So DSU is hard. That's my conclusion. Okay, cool. Well, that was a problem. Yeah, I mean the idea was like pretty straightforward. I mean, in comparison relative to 3,200s, that was a straightforward idea, but code is cool. Probably wouldn't have solved that in contest just because it would take so long. Okay. Yeah, watching someone else practice. Yeah, it's a Mac keyboard. Nothing special about it. Sometimes you debug like that and figure out your logic is wrong. What makes you think your logic is right initially then? Figure out why you settle on a wrong idea. And if you often settle on a wrong idea, then be more careful while you're thinking. And make adjustments based on that. Why don't I look to another solution? I don't know. What's the point? Well, I mean, I need to. I think my solution is fine. Like this, I mean, there could be something more simple, but like the time I would spend understanding it is like I don't feel like it's worth it, rather than just doing another problem. I don't know. It's there's merit in it, but like at this point, like I just need to get better at thinking. I could read the editorial later, but like this solution is simple enough that like this is fine. Like this is probably good enough to be able to do in contests, so it's fine as is. If it were a much worse solution, like the problem I did yesterday, I should probably look for something simpler, but I haven't done that yet because I'm lazy. What? Oh, that's 3,200? Really? Because the standings do not make it look like so. Yeah, okay, I can see it actually. Yeah, this round we died on D. That was a shame. Yeah, I can see it. And then F has no solve, so of course we're not doing that one. I know how to do D. Upsolved. What the hell? Okay, yeah. Cool. Okay. So I'm not going to touch the div ones that I haven't done. Because... How many solves do you have? Yeah, like 3,400 something? 35? 35, yeah. Okay. I haven't looked at this one. We've looked at this one. We've mind solved this. Are there any hard ones in here? Yeah, 3,100. Nah, I don't need to do that. Okay. Oh, 2022. We've mind solved this one. Oh, I forgot it already, but we mind solved it. Yeah, we have code for it. Was it? It was like, yeah. That one's just debugging. Okay, so the rest of these, I don't want to look at these div ones. This one we've, yeah, looked at. Okay, so we're gonna spend a while looking for a contest to do. Because I want to save the div ones for virtuals. This one was unrated, so I don't care about it. This one we looked at. This one we've solved from. How hard are you? Very hard. I'm not doing hello, no. I just don't want to do contests right now. How does this work? That makes you 3,200. And your Deltic's around, which means I'm not going to enjoy it. So it's not. This one I know. This one. Oh, this one. Yeah, okay. How hard is H? Nah. Wait, maybe? You have a bunch of solves. You can look at. Oh. Okay. This actually looks kind of interesting. Let's try it. We can how hard is this? I had tested this round, so all my solves are invisible, but we can try it. Yeah, let's try it. Sure, try both of these. Let's call point of the point admissible. Task is to guess the perimeter. Okay, this is not geometry at all. What? Can't freaking see. Okay, yeah. Bottom left, top right. Yeah. So we can get the area in one query. So we can get the area in one side length, we win. That's noted. Oh yeah, wait, what do we get? No, we don't get the area, we get the number of lattice points, which is different. What does it give us? So if we have a 2x2 rectangle, we're gonna get 9. So we know that width plus 1, height plus 1 is equal to that. So it's the divisors of, yeah, it's still the divisors of this. But it could also be, 0 times 8. Right? Yeah. So it must be a composite number. So, okay, query the frickin', yeah, query the thing. Query the thing, then don't query the thing. Right? That's the plan. What am I saying? Query the thing, then don't query the thing. That's the plan. Yeah. So if we can get a side length, we win. Problem is the rectangle can be really small. But how small can it be? What if its lattice is 12? Then we can get 2, 6, which is 1, 5. Or 3, 4. Which is 2, 3. Whom? Okay. situation is shown in the following. Thank you. Okay, I mean, this is stupid. So if we query a column and we get lucky, right? If we query a column and we get lucky, okay, so if the rectangle's big, that is if, yeah. If the rectangle has a side length of at least 70, then, of at least 50, right? At least 55, let's say. And we can query 3 columns. And it must hit one of them. Query 50, 100, 150. There are not that many possible inputs. I could actually do all of them, yeah. So yeah. Otherwise, we assume both side lengths are smaller than 50. What does that give us? What info does that give us? How does that help us? Well, it makes it harder to find the rectangle. If we get a slice of that rectangle, right? I mean, the smallest possible area that could screw us over is 12, right? Which is 2 by 6. Or 1 by 5. Or 2 by 3. I mean, if your perimeter is less than 250, how many divisors can you have? A lot, right? A lot, yeah. Further, like, if you're 2 by 3, right? Like, most queries are going to hit you. What can we determine? We can, like, spread it out. What if we, like, spread out our queries, right? So if we do that, then we'll lose out on a certain number of points. What was this round from? Go around 15. Wait, why have we done this? Oh, this was the referee round, yeah. What for hacks, the interaction won't be adaptive. Doesn't really matter. Thing. I remembered this time. Pretty sure the links still don't work. It's been 24 hours. It's been more than 24 hours. I'm being lied to. I mean, it's adaptive, which means random is probably not going to work. We need a deterministic way of doing this. 4 is very small. We know our rectangle has to be small. Our rectangle's sides are at most 50 by 50 now. Now we deduce that. Given that, what about it? What about it? example of interaction for the first sample intended to show the format of the queries. Yep. Somehow we need to spread this out. We have 3 queries left. Actually, we don't even know that. No, we don't even know that our rectangle is small because we don't want to waste our queries like that. You know that if the area has to be, if it's big on both sides, then sure. I mean, if it's big on both sides, then what? If we query like half of the plane, and we get the whole rectangle, or get none of the rectangle, then it gives us no information. No extra information, at least. So query has to somehow get part of the rectangle, right? Maybe like diagonals, maybe? Maybe something weird with that? We need to somehow get a side length, right? Can we eliminate multiple things at once? Like you could query a certain gap. If we query like if we query like slices, what does it give us? It gives us not anything really useful, right? It gives us not much that's useful. But like, what does it give us, man? Like, what does it give us, bro? If we query slices, if we get exactly half of the points, right? And that tells us nothing. Oh, it tells us that the side length is odd. That's true. Okay, actually that could be useful. So if we query like split points, right? Well, no, we already know if the side length is odd. No, we don't. Wait, do we? Wait. We know if the area for any divisor, we also have it times 2. Wait, what am I saying? Divisors are 144, right? Most of them are even. Because the only prime factors we have are 3. Yeah. we have 216? Is that better? No, we don't have 216. You have more factors, yeah. Okay, that's true. Stop that. So, I mean, eliminating odd side lengths doesn't really help us that much. Like, pretty much at all. I mean, that would give us... It gives us exactly area over 2. We know the side length is... This is a lot. We can't eliminate all of these using just bits, right? What if we do both at once? Okay, so we know whether the area is divisible by 4, right? But let's suppose we ask you. Actually, wait. If we have a side length that's not divisible by 2, okay, this is interesting. If we have a side length that's not divisible by 2, doing these columns will work. So we want to find 4 numbers and take the GCD of them. That's what we're doing, right? Which 4 numbers do we pick? So if we pick 2, right? We're actually just going to get the same area. If we pick 2, right? We're just going to get the same area. If we pick 2 and we have side length 3, then we're going to get something like 4, which is which when divided by 2 is 2. So we get 4/3. Wait, what? So if we get an 8, right? Then we get a 10. How do you make this adaptive? It's gotta be hard to make good tests for this problem. I don't try to use those things. No, in practice, I guess. ChatGPT definitely not. Oh yeah, it's like maybe if I'm stumped, I guess. In contests, I should do those more because I mean, apparently, given recent events, that it's a good idea to do that, but I probably wouldn't have. Okay, so supposing that we query this and we get 4 out of 6. What does it mean? It means that the portion of the area picked up is 2/3. Which means that this is 2. If we get a 3 on the bottom, right? If we get a 3 on the bottom, that means that the side length of that is divisible by 3, which means that this side length is not divisible by 3, which is good. We get like a 5 on the bottom, right? If we get 6 out of 10, then it's 3/5. Yeah. So what's that mean? If we query 5, it gives us whether the side length is divisible by 5 or not, right? If we query, wait, is it divisible by 5 or? No, yeah. And if we completely miss, if we query like 18 and we completely miss, then it tells us that the side length is smaller than that? What does that mean? We have too many factors to binary search on, but what can we do then? What can we do? So we query like 30, right? Okay, so this gives us a logarithmic number of queries, which is good, but it's still not down to 3, which is bad. Do we still have to query the area? I think we do. And then we query like 18, right? So if this side length is divisible by 18, then we'll get exactly 1/18 of the area. The side length is not divisible by 18. Then we will get something else. We will either miss or hit, right? We'll either get less or more. If we get 0, we completely missed, and that means the side length is smaller than 18. Has to be the length is strictly smaller than 3. And strictly smaller than 18. Sorry, multiple of 18, not divisor. So if we pick our queries, can we pick our queries well to do this? That's what I'm getting at here. Can we pick our queries well? The side length is smaller than 18. Okay. What if we do the factorization? Wait. What if we binary search on the factorization? That's kind of that's kind of crazy, huh? Wait up. That actually that actually justifies the choice of 200. If we query 18, we hit it twice. We get 36 over the side length, right? We get 36 over the side length. It rounds it up to the nearest ceiling. So if we query this and it's not a divisor, right? Unless we get 0 area, which would be a shame. Like, suppose it was a power of 2, right? We query every 64. So if we have 128, right? If we query, what would it be? 16. And it matches, then fine. Otherwise, we know it's smaller than 16. Okay, so that lets us solve for a power of 2, a prime power. But what about more complicated things? Blah. So what's going on? What is going on? So right, like if we binary search on this, so like for example, you can be 0 or 1, you can be 0, 1, or 2. So we'll try something like 2 times 3 times 30, right? Try something like 30, right? If you're a multiple of 30, great, then go up. Just strictly go up on all of them. If you're not a multiple of 30, I mean, if this side length, for example, has 2 times 3, but we miss it, then that's an issue, right? If this side length, if we do hit, if we luck out and hit, right, and the factorization is 6, then 30 times 6, we'll get 36th of the area. We'll get 5 times. Wait. If we hit, we know the exact portion of the area we get. Right? We get 36ths of the area. So all we need to do is hit with a prime factor that doesn't exist, right? All we need to do is hit with a prime. Wait. That's it, isn't it? That's it? How big can this get? Nope, it's too big. 210 is too big. Okay. So that's true, right? Like if we have 128 side length and we hit with 3, actually wait, no, it's divisors of we have more divisors. Wait, this might actually be a problem. 70. Okay, yeah, wait. This, hang on. I'm a bit confused. Thank you for telling me the divisors. Great. Can you please? Okay, come on. Thank you. So that's a lot of divisors. But actually, I need the primes. 2 times 3 times 5 times 7 times 11. That's as big as we get, right? No. Okay, we can have 6 factors. All we need to do, though, is hit with 1. Right? Now we can also do both sides. We're limiting ourselves to 1 dimension. So we can do both dimensions, and that would have an adverse effect. But we're trying to find a side length, so maybe it wouldn't work. I'm not sure. You're trying the E? Yeah, I haven't looked at that one. Could be hard. I think it has less solves than F, right? It's the wrong contest. Now we're looking at this later. Yeah, just fewer solves than F. Nice. Okay, so is this auto-generated? This is auto-generated, right? Great. Okay, cool. Thank you for the useful info. Yeah. Okay, so suppose then suppose we query 3, right? No, wait, no, that's a problem. Wait, is it a problem? Yeah, we get a fraction. We get a fraction, don't we? We get 3 times k over the side length. Three times k over the side length. We don't know what k or the side length is. All we know is the fraction k over side length. Right, so the query result is 3k over side length times the area, right? So q over a, 3k over side length. We don't know what k or the side length is. What we do know is that k is either ceiling or floor. S over 3. It's one of those two. It's S over 3 rounded in one of the directions. Does that give us the... Maybe that does give us the thing. It's like we're given a fraction, right? If the side length is divisible by 3, yeah, otherwise not. The problem is k and s could be not coprime, right? Like if the side length is 14 and we round down to wait, what? Wait. No, wait, that's... Yeah, wait, if we get 14, right, and we get 12 over 14, then it could be 6/7. Or it could be... always rounded s over 3, right? So if we have a side length of 14, and we get 4 such points, and we get 4/14ths of the area, which is 2/7 of the area. We know that 3 is coprime with that. So we can just ignore the 3. So we know that the side length must be divisible by 7. Guaranteed. That's what it gives us. Somehow we get 7 from 3, right? How does that work? We know it's not divisible by 3. That's what we get. We know it's not divisible by 3, but we can't necessarily glean any information from anything else, right? We can query divisibility. That's what we can do. Query divisibility 3 times. We can tell if the side length is divisible by 3 or not. Right? That's what it gives us? This problem seems very tight. Something's tight about this problem. It seems like the limits are tight. We can query divisibility. But this gives us no more info, right? Well, what does it give us, right? If we query divisibility, right? Then we get a guaranteed factor that's at least 3. Right? If you're 21 and we do 5, and you round down to 20, you round down to 4, right? Or 5, for that matter. You're 21 and we get you to 5. For 21, we query 5 and we get 4 points back. And we know A, you're not divisible by 5. B, you're divisible by something bigger than 5. Right? What do we, wait, if we query, okay, say we query 180, right? If we hit with 180, and you're not divisible by 180, and you're like 3 or something, right? Say divisible by like 7, right? If we query 180 and you're divisible by 7 and you actually hit, which has a low probability, but suppose we do, what do we get out of it? Query 180, we get 7. Query 180, we get 7. Right, it's like 180. If we query something that's near a multiple of 7, right? Like what if we query 48? Well, either we hit or we don't. If we hit, we get 1/7 of the area, guaranteed. No, we just get 1. Yeah, we just get 1. Yeah, wait, what am I saying? It doesn't, no, I'm high. If we query 180, either we get 1 or 0 divided by 7. It's 7 over S. Yeah. So either we get 1 or 0 divided by 7. If we miss, we get 0. If we hit, we get 1/7 straight up. It's X over S. Wait, no, it's S over X. Wait, what? What are we doing? Yeah, it's S over X. So it's 7 over something. Can we glean it from how close it is to the area, though? I mean, like, if we get, if we query 3, right? If we query a factor that doesn't exist as part of the number, also we can have at most 5 distinct factors. I'm being high. Well, a little bit high, but not really. If we ask about the factors, you're going to be able to get more information from this. And if we ask 7, right? And it's 2. If we get 7 and hit with 2 4 times. Well, no, right? That was the issue, that it's floor to ceiling, so that it could become a lot of things. So, like, for example, we can't distinguish if we query 3, right? And we hit 7 twice. We can't distinguish that from hitting 14 4 times. Or 28 8 times. Well, 28 8 times can't happen. So actually we know it's a multiple of 7 and it eliminates like most of the factors, right? Right? It should eliminate most of the factors. Okay, so we just need to not miss, right? We just need to not miss. If we miss, we're screwed. If we don't miss, right? Like, let's say we query 7, right? If it's 2, we could get 3 7s or 4 7s. Now, if it's, no, wait, what? We query 2. If it's 7, say, we can get 3 7s or 4 7s. If it's 14, we'll get 1/2. If it's 9, say, if we query 2, right? For any even number, we'll get 1/2. For any odd number, we'll get it directly. Yeah, because rounded x over 2 has to be coprime with odd x, because like math, right? Am I correct? Yes, because any factor is not near x over 2. It's at least 3. Yeah, okay, sure. Except for 3, I guess, but that's fine. Let me just get 1/3 directly, which is fine. Yeah, it's still coprime. Okay. So if we query 2, if the side length's even, we get it directly. If the side length's odd, we just get the side length. If we query 3, Also, if the side length's, yeah, if the side length's 1, then we miss it entirely, which is fine. But that doesn't really help, because a lot of side lengths can be even. Both of them can be even. We need something that works for powers of 2 as well. Like we could be given an area of 128. And then we need to know that yeah. Is there small big going on here? If small, do something. If big, do something else. We have 7. If we query 7, right? If we query 7, I don't know why I'm so fixated on 7, but if we query 7, if we query 7, what does it give us? If we query 7, if we query 7, if we query 7. So if the side length's like small, so if we have 2, right, querying 7, if we get a multiple of 7, that's fine. If we query 2, right, then we'll get 3 7s or 4 7s. If we query 3, no, it's not 3 7s or 4 7s. It's, what are you? Are you? Wait. No, it's not. No, it's not. It's not. It's not. It's not. Is not. We need logarithmic. Wait, no, that's. Wait, yeah, we can. Can't we? This is dumb. Hang on. Okay, I mean, 2 to the 8th being 256 is like, that has to be a thing, you know? Like, suppose we start off by querying 13. Or 14. 13, let's say. Right? If you're a multiple of 13, great. We've reduced the search space by half. If you're smaller than 13, okay, then we've reduced the search space by half. So we query 13 for simplicity, right? So we do the geometric mean binary search. That'd actually be cool if that were the solution. I've never done that. So suppose you're smaller, right? If you're smaller and you hit, right? That it's going to be a direct fraction. The thing on top is going to be 1. Which means that it's going to be a direct fraction, and the thing on the bottom is going to be smaller than 13 as well. So if we hit, we're done. We're just straight up done. If we miss, that's fine. Playing freaking Battleship here. This is the Battleship problem. That's what this problem is. This is generalized Battleship. I just realized. Training before Olympia. Is that on this contest? Send me that after this. I'll look at it. Unless it's like way too hard, but if it's not way too hard, then I can look at it. Probably after this one, though, I want to keep my train of thought. So, okay, let's write some goddamn code, dude. Okay, look. So for all I is 2 y. 2I is less than or equal to 200 I plus plus. LRA is, so it's, yeah, I over 13. LG is GCD I. Cout A I over G. Do the same thing here. Okay. Yeah, so I mean, right? Like most of these are different. But not all of them, right? Like 13 and 14, right? We could get 2 hits. Then we get 1/7. So we get that you're a multiple of 7. What's the smallest such fraction here? How about 16? Const ls is 16. Nine still. Damn. That almost works. That really almost works. What is with 18? Try that, huh? No, then you're 12. Wait. Wait, what's 200 over 9? 22. This is very close to working, actually. This is very close to working. It's one number off. It's one number off, right? Well, no. Yeah, wait, that doesn't work. So even numbers, you could be 2. Actually, wait. No, like most of the, wait. No, this is fine. Okay, yeah. So this works. This just works, right? This just works. So we find a thing such that you result in the smallest possible group. Okay. All right. So set LST4 L equals 1. Let's go to 200. Void gr set map elo set elo for elo I elo a is I k over x. Wait, what? Wait. Yeah. No, it's x over k. LG is GCD AX. MP. Insert x. We do the same thing here. X plus k minus 1. X over g. GR ST16. Okay. For auto XY MP PRXY. Okay, sure. Void cell. V is equal to GRSTI. If V is less than MV, MV okay. So I believe this works. Wait. If wait. D. So we have 3 queries. We do 1, then we split that setup, then we do 2, then we split that setup, then we do 3. D is greater than 0. D is greater than 1. Return MV MI. T is equal to Y D minus 1. Why am I doing this? Why am I manually enumerating the multiples of 14? 1. Wait, what? No, that's not right. Oh, wait, no, 196. Yeah, okay. Okay. Wait, why are you so slow? It's 200 squared, isn't it? So this is 200, this is 200. And this is 200. Yeah, okay, this is fine. We'll just greedy it. We'll greedy it, screw it. Pair, greedy should work, right? LO, map, okay. Okay, good. So, all right, so local. CD0. There are no multi-tests. Okay, so now. Oh wait. For I equals 1, I is equal to 200, I plus plus. If r mod I is equal to 0. There we go. Okay, that's even better. So then so I st one dot s if I wait, what are we doing? Doesn't matter. I mod c is equal to 0. So we're doing query points. Well, n is equal to what? So it's r times r. LD is equal to c. Auto MP. Okay, so st is equal to mp nd. What? Why? ARRC. No, it should be on the bottom somehow. Oh wait, yeah, it should be Q over A. Wait, what? Wait. Wait, what am I doing? Yeah, no, it should be just R and AR, yeah. And that is correct. AR over B. Indeed. Then C out 2 times V plus OV minus 2. Beautiful. Okay. Perfect. Sure. Okay. Beautiful. I guess this works. Either your wrong answer on test 1 or you pass, right? That's the deal. Okay, but pass. Do something. Come on. Are you gonna ILE something like that? Fine. Do I have to read in something at the end? No, okay. Good. Nice. Beautiful. Okay. Good stuff. Good stuff. Okay, what is this training before Olympiad? Is that on Codeforces? Calling it is, yeah. Keyboard is just the Mac one. That's all. Like just the Mac built-in one. Nothing special about it. Just watch this run. It's gonna pass all the cases. It passes all their tests. So if it passes 100,000 of my tests and 67 of their tests, it's probably correct. Hopefully. What is this? What is this input format? What? Okay, that's interesting. I guess it's like parameters to the interactor or something. Maybe it's like a seed. Yeah. Could be a seed. Wait up. Hang on. Did they? They wouldn't do that, right? Did anyone FST this problem? I FST'd G, by the way. I got a runtime error because I had a stupid thing. Yeah, and I had a wrong answer because it was an out of bounds. That was fun. Did anyone FST this problem? No, I guess not. Nice. I don't know, if you pass one case, you probably pass them all. How did I stress test? Okay, so first of all, you have this if local. So first of all, local is my local parameter. Where is it? Basically, I have this. If def go colon local, then set local to true and have these debug statements. And then in my, okay, stop. In my compilation command, I have that defined. So that every time my program is run locally, this will be defined, and otherwise it won't be. So then if local, there are multi-tests. Now in each multi-test, just randomly generate a test case and then make sure it's valid. And then we have, this is how I do all interactives, by the way. If it's local, then compute the answer locally. Otherwise, actually do the interaction. But here, since we have the test, we can pretend to we're the interactor. We can pretend that we're the judge and just compute the answer manually with the program given the test case. And since it's running multi-tests and since the test is generated each time, it's just gonna work as a stress. And this works for pretty much all interactives where the test cases are easy to generate, so it should be fine. Yeah, it works easily on samples. You can easily modify it to make a stress test, etc. And it's not set C. Well, it's just where is it? MT, this thing. The seed is the time of the program run, but it doesn't really matter. It can be set. I just leave this random because if I don't, I'm going to forget to later, and then I'm going to get hacked for it. So I don't want to do that. Yeah, anyway, that shouldn't have worked. It was weird that that worked, but I guess it did. I don't. We'll look at the editorial for this later. I'm kind of curious, like, if that's intended. It's probably. It could be intended. Like, there's a decent chance that it's intended. I don't know, though. Let's see. I has no solves, right? Yeah, it has some. Should try. Do we do I? Good question. Probably not, right? Probably not. Probably not. I don't know. It has a bunch of solves. Let's just look at it and see if it's gonna be painful or not. There'll be n singers who will perform identified by the integers. You must choose in which order they're going to perform on stage. You have m friends and each of them has a set of favorite singers. Oh. Well, that looks hard. Yeah, that looks fun. Okay. Maybe we don't. Let's not. It's 3,400, right? We're allowed to skip that. Um, Probably later, I guess. Like I could, but I want to, I don't know, use this time to get as many problems in as possible. FST, huh? That's rough. Actually, a lot of FSTs. Why are there so many FSTs? Did he TLE? Yeah, of course he TLE'd. Of course. So that was 3,300, huh? That's cool. Do we want to try I? Do we want to try I? Do I actually want to think about it? Like probably not, right? Like we have. Yeah, probably not. Probably not. Did what in 2 minutes? I? What's with E? Is it special? Or is it weird? Special and or weird. Yeah, this one went well. Don't need that. We can close that. Okay, wait. So what happened with this problem? So we... Oh, there's similar problems. Yeah, it seems kind of standardish. Okay, maybe not then. Oh, yeah. Okay, maybe not. Maybe not. Maybe not. That's a good point. Maybe not. If okay, yeah. If this guy solved it, then it's definitely nah. That's not intended as beef. I'm just saying like he knows a lot of stuff. If he solved it in 24 minutes, then yeah, that's gonna be well known. Oh, the freaking virtualer. Okay, yeah, sure. That's that's what you meant. I see. I've looked at goodbye. I don't wanna do its problems. Like I've heard both F and G were internet, which I am not a fan of. Okay, well, that's that for this. We'll try D2 from this one. I tested this round. I never solved this. Right. Oh yeah, right. I remember this. I remember why I gave up on this problem as well. Why are you 3,300? Wait, what? Okay, I need to think about what happened with this problem, right? It's like this problem was weird in the sense that that it was very heuristicy, that you pick a point, pick a strategy, hope it partitions the possible things well enough, and then do it. I guess that works. Yeah, that works. And it's fine. And everything's good. And you write code to make it work, and then it works. That's problem solving for you. Writing code to analyze brute forces. That's the plan. Well, whatever. Okay, so this round wasn't actually that great then. If G was weird, H was whatever the hell that was, and then I was well known. That's a shame. Okay. Yes. Let's remember how to do this. Let us remember how to do this. So, a cow strictly inside the fence is said to be enclosed. There are an odd number of enclosed cows, and the area of the fence is an integer. The fence is said to be interesting. We can do some like, what is Pick's theorem again? We need to, is there an odd number of enclosed cows, and the area of the fence is an integer? It's still working, right? Yeah. Suppose the polygon has integer coordinates for all of its vertices. Let I be the number of integer points interior to the polygon. Let B be the number of integer points on its boundary. And the area A of this polygon is Cool. Cool. Cool shape, bro. The hell? I be the number of integer points interior to the polygon, let B be the number of integer points on its boundary. What? Okay, come on. The area has to be an integer. So interior is always an integer. So boundary will be an integer if and only if so the area is always an integer with even, right? Because like well, no, wait. Yes. Wait. Is it? Wait. Boundary includes corners, right? So even. So do we have a point X and Y? Then the number of points on here are going to be what exactly? Is it the GCD? That's the GCD, right? Yeah, because then for everything divisible by the GCD, you can break it up. Like you can break it up here. This will be an integer coordinate. And you can't have any more because magic. If it's not the GCD, then it's not divisible by x, then it's not an integer coordinate. Yeah. Okay. So the GCD is even, then there are an odd number of points on the boundary. And since there are 3 corners, yes. How do we do interior points then?
Let me mute the mic, right? Yeah. So if we have even, oh, strictly, okay. So the point is area is always an integer. So all we need is interior points. So how do we do this? So also have shoelace. Yeah, shoelace shows up. Okay, how does this work? Just give me the general formula. Okay, we'll take this one, I guess. Doesn't really matter. Yeah, sure, this. So the area is always integer. So we only care if the area is even or odd. So we only care about mod 4. In boundary, we only care if the GCD is 4 or not. So again, we only care about mod 4. So we can take all the points mod 4. And that's it. Okay, yes, that's how we do D1. D2 is, of course, harder. So now, okay, so we need two conditions. We need the area to be an integer, and we need the enclosed cows to be that. So we can't only care about mod 4 anymore, right? Can we? Mod 4. No, mod. Okay, wait. So we care about GCDs. Do we? Wait. Do we? Yeah, so we need the GCD mod 4, don't we? Right? We need the GCD mod 4. Wait. What do we? What? Come on, focus. What do we need? So the boundary points is 3 plus yeah. Yeah, that's why the even thing matters. The boundary points is 3 plus 3 plus what? 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 Come on. 3, right? It's the corners plus the sum of the GCDs of all the differences. So, if you're even, okay, so there are some things. Yeah, that's where this gets weird because we need both GCD and like other things. We need GCD and other things. Right? Offense plus line distinct coordinates. Yeah. And we can compute pairwise GCDs. Wait, can we? Wait. 6,000 squared times 4. That barely works, but it does work. We're allowed to compute pairwise GCDs, though it would be slow. Like, not that slow, because you can't. Well, you could do the Fibonacci case, but that'd be like 3,000 squared. That's fine. And squared over 4. Wait, what? Wait. So it's n over 2, choose 2. N squared over 8. Ah, yeah, that makes sense. Okay. Yes. Indeed. Okay, so coordinates being odd. So right, odd number enclosed cows, integer area. So we absolutely need the boundary to have an even number of points. Which means either all must be odd, so all must have, it's GCD minus 1, right? So we can assume it's some GCD because we can add 1 for each corner. So it's some GCD. So we need all the GCDs to be even. Or 1 is even and 2 are odd. If all are even, that's simple, right? So all are even, or 1 is even and 2 is odd. 2 are odd. Let's enumerate the even one, right? And then worry about that later. So let's say enumerate the even edge. If we enumerate the even edge, right? And there's something else. So either we can do even, or we can do something of the same parity. Or we can not. We can do something of the same parity, right? So it has to be either same parity in both, or something else, of course. Either same parity in both, or anything else. That's all the possibilities. Thank you. Well, if it has not same parity in both, so we're enumerating. What are we doing? We're going through points of the same parity. Like we know 2 of the points have to have same parity in both. 2 of the points have to have. So if I'm odd, then for you to be valid, we're iterating over the even edge. So you're going to be odd as well. Then either we need 1, 1, and 3, 3, or 1, 3, and 3, 1. We can't use bit set. No bit set allowed. 6,000 is pretty big, yeah. So we need you to be even, and further we need you to be a multiple. No, we need you to be even. So this is an integer. The area has to be an integer. What's the constraint that the area has to be an integer? What's shoelace again? So, okay, so there are 4 possibilities. Odd, even. Yeah, right. So suppose we have even. If we pair you with another even, you're easy. If we pair you with, say, odd even, then we get this cross product for both of the edges. So for the area to be an integer, right? Suppose we have odd, and we pair you with odd. Suppose we have odd, and we pair you with odd. Suppose we have odd, and we pair you with odd. suppose we have odd, odd, and we pair you with odd, odd. So if we pair odd, odd with odd, odd, it's always going to cancel, right? Because these two have the same parity. So like, this product, regardless, is going to have the same parity. And yeah, okay, so the area is always even. But what is it mod 4? So we care if the area is even or odd. I mean, sorry, the area is always an integer, because this 1/2 always works, but what about mod 4? What about mod 4? Well, what? So and we can still, like, for this sake, we only care about the coordinates mod 4, but for the GCD's sake, it doesn't work that way anymore. That makes it more complicated. But the GCD, right? It'll either be 0, I mean, it'll be one of those. It's like if you have the same mod 2, right? Like we could absolutely brute force this casework. If we have odd, 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 even, right? So if we have same parity all the way through, then if we have same parity all the way through, then all we need to do thus is well, we know the GCDs are going to be even. So we just care about the GCDs mod 4. No, we care about what? Yeah, we care about the GCDs mod 4. So no odd thing is going to help us anymore. So it doesn't matter. If we do odd even, say, we know one of the things are going to be odd, the other is going to be even. So we don't have even anymore. So we know the GCD will be odd. What about the odd point out? What if we iterate the odd point out instead? So we iterate u, and we say we're going to take an edge that has the same parity. Well, there could be a lot of such edges, right? Feels like iteration isn't going to go anywhere, like smart iteration. Needs to be n squared, maybe n squared log. Where's this guy from? Okay, sure. I noted popularized in English. That's interesting. Like I plus b over 2 minus 1. I plus b over 2 minus 1. So I is odd if and only if the area and b over 2 are the same. So it's shoelace over 2 plus b over 2. We know that for the sum of the GCDs to be even, which is necessary. Wait, that's an equivalent condition. What am I saying? Of course. The sum of the GCDs to be even, so that b over 2 is an integer. Yeah. Okay, let's think of this a different way, right? So for each segment, we have the points strictly under u. Well, that doesn't necessarily help, right? For each segment, we have the points strictly under u. Should charge my stuff. I was told in testing that this would be 2700, by the way. Just a little anecdote, because that turned out to be very accurate, as you can see. 2700. Yeah. Okay, we gotta be smarter. We gotta be smarter somehow. So interior points, right? Can't do mod 4 anymore. Interior points. What does it mean for a point to be interior? It means it's strictly inside. So, if we do the points strictly under, right? Then what? Then what? That would also be n cubed. So that wouldn't really work. So the next n lines contains two integers, x and y. X, y is the coordinate of a fence post. area of the fence is an integer, the fence is said to be interesting. Enclosed points. Okay. We can count the things with integer area. That's easy. All we need to do is fix one side and say that that side will be same parity. If we fix one side and say that side will be same parity, then it's fine. $29. If we fix one side and say that side will be the same parity, then it's fine. So that handles one of the conditions, but not the other condition. If all are odd, let's say all GCDs are odd. Oh yeah, then there can't be an odd number of enclosed cows anyway. So actually the area being an integer is a useless condition, right? No, not necessarily. Well, no, that could cancel. And there are certain states mod 4 that are going on here. If shoelace and boundary are different mod 4, if they're like 1 and 3 mod 4, for example, then there'll be an even number of enclosed cows. If shoelace and GCD are different mod 4, shoelace and GCD are different mod 4, then you'll have like 1/4 here. And you'll have like 3, you'll have 1/2. No, yeah, what? Wait, what? Wait. Yeah, what? Wait. What? You'll have 1/2 here. You'll have 3 halves here. So this cancels. This becomes 0, and this is an integer. So for the condition to be satisfied, A and B have to be the same mod 4. That is the only condition. No, the area has to be integer. But if the area is, no, yeah, so A and B have to be the same mod 4, and B has to be even mod 4. Those are the conditions, right? if you have to be the same mod 4, we need a better function than GCD. GCD is very hard to analyze. What do we do at GCD? Ten to the 7th. That's interesting. So it's the GCD the differences. It's GCD the differences between the coordinates, right? What's that mean? What does it mean for it to be the GCD the differences of the coordinates? That every factor that's 1 mod 4 doesn't do anything. Every factor that's 3 mod 4 is relevant. Ow, is relevant. It flips the sign. And if you're even, then it just depends if you're exactly mod 4 or not. Every factor that's 3 mod 4. So 3, 7, 11. Shoot. Every factor that's 1 mod 4 is irrelevant, right? Because 5 mod 4 is 1. 13 mod 4 is 1. 65 mod 4 is therefore 1. Every factor that's every factor that's hello from Italy. Yeah, I'm back in Maryland, but hi. Are you still there, actually? It's a long trip. Are you there for like the whole break? Anyway, 3 mod 4 is negative 1 mod 4, which flips the sign. What's that do? What's that do? What's it do? We just did 15, right? Yeah. Wait, did we? We did G and H from it, right? Yeah. Okay. Let's see if there are other formulas that exist. Well, that's cool. Cool stuff. What about the other area formulas? What is Heron's? Heron's is side lengths, right? What? Okay, well this doesn't help. Because side lengths can be square roots, which is complicated. Does it help? Well, I mean, no, right? That's very complicated. Very, very complicated. Not that good. Not very good. I kind of don't feel like doing this anymore. I don't know. I feel like this is knowledge, but I don't know. I'm not convinced that the solution is nice. Because, I mean, D1 was like formula bash, pretty much. Not convinced that the solution is nice. If it's not nice, I don't want to figure it out. I mean, it is required for 3100, 3200. Unfortunately. I'm just not convinced that the solution is nice. What do you do? Nice. I'm gonna look at it later. Let's do the coder, because it's about time for that. Okay. C and D are the same points. Okay, I'm going to bear back. And then we'll do this. Cool. Alright, let's do this. You are long. Yes. Okay. I've got to do better on these. I'm not as tired this morning, which is cool, but we'll see. Okay. N slices of toast and M. That's big. N slices of toast and M plates. Yeah, okay. Sand and decay, VIN. AI plus A 2 times dupe minus 1 minus I. For I equals 2 times dupe, I is less than N. Okay, yeah. You get the right answer, right? Yeah. VIN, LXA, C into X, sort. Dupe is N minus K, I is 0, I is less than dupe, I plus plus. That's plus equals square AI. It's A 2 times dupe minus 1 minus I. Alright, we want to pair the smallest. So you have to be on the plate together. So we'll pair the smallest with the biggest. Yeah. Yes. How many times can the product of all positive divisors of A to the B be divided by A? What? Okay. Cool. Clap. Good. We're fast. What does this mean? The product of all positive divisors of A to the B be divided by A. So factorize A, sure. Then you have factorize A. For each prime factor, you have this count and this many divisions. You have this count and this many answers. Okay, cool. So this seems like do thing problem. You know what I mean? Do things. So we have like, if it were 4, say, right? 2 to the 2. Then we'd have more divisors. Yeah, if it were 4, then we'd have more divisors. So we'd have this many ways to choose and a sum of big. This many ways to choose and a sum of what? So it'd be this times b choose 2, right? This times b choose 2. This times b choose 2. Yes. Right, so we'd have count so you'd have what would you have? What would you have? You'd have, so if you have to the k, then you have k to bk, which is bk minus k plus 1 choices. And you have sum this. To converge 2, you'll have sum times count plus count times sum. And then you'll have count times count. Right. Okay. So cn to x to y, number theory. BL f is equal to factors x LO CS is 0, CT is 0. For LOXF. Okay. LLCT is RT is y mod mod. Mod is this. Need mod op as well. Y mod mod times C minus C plus 1 plus mod mod mod. RS is equal to, so your what are you? So your y mod mod times C mod mod plus, so it's C times y choose 2. C times y mod mod times y minus 1 plus mod 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 times mm2 mod mod. LNT is equal to CT times RT mod mod. NS is equal to CS times RT plus RS times CT mod mod. CS is equal to NS, CT is equal to NT. C out, CS, yeah. 9, Y. RT is 3, so we have 3, that's true. Why are you this? So you're 3, right? So you're 1, 2, 3. Idiot. Okay. Damn. Wait, what? Wait. Hang on. Wait, no, what are we doing? It has to be all of them. Yeah, wait, I'm high. It's just a large geometric sum, isn't it? It's just a large geometric sum. So it's, yeah, wait, yeah, this is wrong. It's all that are greater than or equal to this, plus all the ways to choose. Oh yeah, wait, okay. So it's the product of so you have n over c plus, so you have nc plus 1 minus c. nc plus 1 damn, you have nc plus 1 minus c, the product of that. Minus 2c, product of that, minus 3c, etc. up to yc. It's the number of ways to choose something that divides at least once. Times the number of ways, plus the number of ways to choose something that divides at least twice, etc. So you have n minus k times c. Right? So this parameter is constant. So we need to get you in terms of a polynomial in the c's, right? So we have x c wait, what? Yeah. So we have xc plus 1. So we have 2x plus 1, right? Sum of x to the k fixed k. Now what? What are you doing? Alright, we can do that. Yeah, okay, sure. Okay, so VLP is equal to 1. For auto f p mul p 1c. Okay, yeah. Right, so that's 0, 1, 2. Okay, so, right. So how's this work? Wait, we need the sum of x to the k for fixed. Ah, come on, you know what this formula is. Do you? No, you don't. Yeah, that's over k. Come on, what is this? I know what this formula. This is so dumb. I can't freaking. Bro, this is absurd. Up to n. So I mean, we need sum of x to the k for that, right? For x equals 0 to n. X equals 0 to y minus 1, right? How is this not available, dude? How is this not available? Okay, Jesus, like something. Stop. Okay. Thank you. I need. Yes. Is there a better way to do this? I swear to God, man. What is this? Why can I not? Like, we need you up to... Swear to Christ, dude. Okay, let's just... For L I 0, I is less than P dot size, I plus plus. For J is 0, J is less than Y, J plus plus. Ants equal to ants plus mpow J I times pi mod mod. Let's make sure this is correct, right? No. Do you work for this? Why do you not work? Wait, what? It's the product of... It's mod that mod. Okay, now I'm confused. Now I'm very lost. Now I'm very lost. So we need the sum of... Y. Four, 3, right? So the divisors of 64. The answer should be way bigger than that. Should it? Wait. 64. So there are this many ways to pick a number that's at least as big as you. There are this many ways to pick a number that's at least as big as you. There are this many ways to pick a number that's at least as big as you. Right? I'm so lost. I'm actually so lost. I'm so lost by this problem. There are this many ways to pick a number. There are it's at least, if we have 6, right? We do 6 to the 10. There are, how many ways are there to pick a number that's a multiple of 36? Right? How many ways are there to pick a number that's a multiple of 216? Right? It's 8 times 8. How many ways are there to pick a multiple? A number that's a multiple of that, right? So it's n minus k. So it's nc plus 1 minus kc, right? nc plus 1 minus kc. N minus k times c. For k equals 1 to y. Am I going crazy? Okay. So for Lj is 1, j is less than equal to y. R times, so your y times c minus j times c minus 1 do you not work? You don't work. Okay. Well, that's confusing. product of all positive divisors of a to the b be divided by a. Oh. 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 I'm confused. Yeah, it's back to here. Yeah, I'm confused. I'm actually lost. It has nothing to do with this. Right? So, I'm actually lost. Actually lost. Genuinely lost. So, I mean, there's only one factor, right? There's only one limiting factor. So we only really care about one. I'm actually crazy. What am I doing? Look, so look for 2, 2, and 4, right? So 144. So we look for the max. We look for the max count, right? Then is it max or min count? I don't know. We get more intermediates. It's divided by 2, but it's exponential. It's exponentially more. I'm losing my mind. A to the B, right? So like none of this matters. All we need then is the count of the max divisor and we need the and we have the formula already, right? No, we don't. No, it's YC choose 2. YC plus 1 choose 2 times YC plus 1 for the rest, right? VLT 4 auto CV T dot push back C. Is equal to Y mod times C plus 1 mod. P is equal to P times S mod. P is equal to, so it's YC R K is equal to YC plus 1 times YC over 2 mod. P is equal to P times K mod. P is equal to P times MIMV R mod. Jesus. Y mod mod times C plus 1, P times S. Yeah. Okay, that took way too long. Good. MST online plus plus. Given positive integers n and k in a sequence of n positive integers. Ugh, seriously? Are you a mod issue or what? And this is fine. This factors S. Do you get the same answer if we don't? Bro, this is so annoying. I hate this problem. What? Alright, okay, fine. Gonna get the same answer. Okay. F is factors S, map L V for L of X F plus Vx. Y mod mod times C plus 1 mod mod. P is P times S mod mod. YC is Y mod mod times R mod mod. Why do you not work? Why do you not work? C into X to Y, gen primes 1.2 is 6. VLF is factors X. Map L of V for LXF plus Vx. VLT for auto underscore CV T dot pushback C. Sort T dot begin, T dot end. Doesn't matter, right? R is T dot back, T dot pop back. P is 1 for LLCT. S is Y mod mod times C plus 1 mod mod. So C is at most like 40. Auto underscore CV. Y mod mod times C plus 1 mod mod. YC is Y mod mod times R mod mod. YC plus 1 times YC over 2 mod mod. Right, so we're modding with Y every time we use it. We're guaranteed that we have at least one factor. What is this? What does that mean? How do you fail all of those tests? Square, odd, even. Okay, we've got to do something else. We've got to do something else. This is absurd. How much time do we have left? Okay, we can come back to this. Jesus Christ. You're given positive integers n and k in a sequence of n positive integers a. P1 to n of 1 to n. A weighted undirected graph G with n vertices numbered 1 to n. Okay, I'll read the other one. Permutation. Given a permutation. Permutation Q. Okay, so I mean, so you have to make it a cycle permutation, right? So we So, I mean, the swaps are going to form a tree. Right, so like when we move an element out, like if we move an element to the right, right? So I mean, we consider the smallest cycle that 2 is a part of. We consider the smallest cycle that's a part of 1, right? We want the smallest possible element to be there. The smallest possible element is going to be either this or this, right? So we look for the smallest element not part of this cycle. So like for the first cycle, right? For the first element, we want to make it as big as possible. It's like 2, 1, right? 2, 1, 3, 4. So we'd rather do this, yeah. So we want to make the first element as small as possible, right? So we look for the first element. We look for the first element that's not part of this cycle. Okay, wait. So if the cycle is contiguous, right? Then we have to swap some other element with it. Let's swap the smallest one. If the cycle is not contiguous, like it could be 3, 1, for example, right? Then we're going to have a 2. Well, but this could point to a contiguous part. So we could have like 2, 4, and then 1 there, and then 3 would be there. But then at least one of the elements must be smaller. At least one of the elements must be bigger, otherwise the cycle would be contiguous. So given that the cycle, otherwise if the cycle is contiguous, you swap the last element with the smallest of the next, and then continue. But what about intermediate swaps, right? Like what if the 3 is at the end here? And we could swap the 3 with this, then we could do that, and move the 1 there. But we wouldn't want to do that. That would make this bigger. If we have like a 3 here, 4, 3, 6, 2, yeah. You're gonna form a cycle, right? So we move the 5 as early as possible. So if the first cycle is not contiguous, then we have to move the smallest element over. Do we want to do any swaps before then? For example, would we want to move that smallest element somewhere else? We could have a very big element here. Like we could have 10 here. Like 2, 10, and then 1. Right? Two, 10, 1, right? Then we move the 3 here. Maybe we want the 10 to be later, right? Then if we swap you with the 3, we move you to the 10. Like either, but then when we do this, we have this freedom, right? Don't we? Two, 10, dot, 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 1, right? understand. 2, 10, dot, 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 1. All right. So if we have like a 3 here, maybe we want to move something else here, 3 here, then move the 3 here. But then we could accomplish that same shift with the other sequence of swaps, right? We could accomplish 3, 3, 7, 10. Yeah, it's 2 swaps that lead to the same thing. Okay, yeah. So the other swaps are going to lead to the same thing. Okay. Sand n. Okay, so if you're contiguous, so first permutation. If you're contiguous, do the minimally damaging swap, which is at the end. Otherwise, if you're not contiguous, do a beneficial swap. Then ignore the rest of these elements. If you're not contiguous, do the rest of these elements. If you're not contiguous, do the rest of these elements. Right? Then do the rest of these elements, do the rest of these elements, do the rest of these elements, right? If you're not contiguous, do the rest of these elements. And therefore we have that you lie on this line. And we ignore you for the rest. And we go through, if we visit the entire cycle, right? Look for the next smallest element. Okay, VL lab n -1 size n. For I equals 0 is plus if lab I is equal to -1. While lab I is equal to -1 plus size c, lab I is equal to c, I is equal to AI. Okay. If lab I is not equal to last, if size last is equal to 0, swap I minus 1 lock I. Else for x at last if x is greater than I, swap ax, swap ax I, break. Okay. 2, 1, 3, 4. How? Why? Swap size last is 1. Label I is not equal to last, right? Wait, what? What? What do you mean? Oh, idiot. Why? Why? Why do you do that? Oh, that's why. What? Wait, okay. That should not. Goes 3, 2, 5, 1, 6, right? Then we do 4 and 5. How do you get 7? Oh, if lab I is greater than last, that's why. 5, 2, 7, 1, 8, 9, 6. Yeah. 2, 1, 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1. That's why. Yes. C into n VLAN. C into x minus x. Lab I is negative 1 plus plus IC. Component dot pushback I. Lab I is C. I is AI. Yeah. VL lock. If lab I is greater than last. So if size last is 0, then move I to the position I minus 1. Oh, no. It's at last dot back. Yeah. Shouldn't change anything, but size last is 0. Swap at last dot back, lock I. Size last is 0, right? Then swap at last stop back. Lock I. Can't do better. All of you are part of the same cycle. Wait, no, we can do better. Oh, we can absolutely do better. Wait, what am I saying? Yeah, wait, I'm high. No. Yeah, this doesn't work. Why are the samples like this? So if you're contiguous, the strategy is the same, but if you're not contiguous, right? If you're not contiguous, then what the hell? If you're not contiguous, then what? You have some bigger element, right? Then we'd want to replace you with the first element that's bigger than 5. We want to merge you so if we have something like, if you're say here, right? 2, 10, or rather like 10, like 8, 7. One, 2. Then we have 4, 3. And the answer for you should be that. But it won't be. Yeah. The answer for you should be 3 and then 5. Three and then 5. So this case is broken. What we need to do is find the first element. Yeah, I mean it's pretty descenty. What we need to do is find the first element. So say you're greater. First element such that you're greater than or equal to this. Okay, I guess we're doing this, huh? Let me do max. If tree I turn TL, turn -1. FFTLMV. Don't really need size anymore. I 0, 0, and -1I. Where? Do I have multiple STs? No. Oh, you're void. Swap v block I. Why? Dot val. Yeah, okay. Good. Yeah, for 1, 2, 1, 2, 1. Yeah. st.find first 0, 0, I minus 1 I. V is min v I minus 1. Yeah. I mean, this is pretty straightforward. TL is TR. If 2 right out val is greater than or equal to V, return TL, return -1. Eval lazy, 2I minus 2I plus 1, TL TR. TL plus TR over 2. Tree 2I minus 1. Dot val is greater than or equal to V. Yeah. Okay. Well, that's cool. Probably gonna get wrong answer, in which case I will debug it. Nice. Okay, MST online plus plus. Runtime error. What? How are you runtime erroring? How? Wait, where? Wait, what? Wait, what? C into N, VLAN, or LLXA, C into X minus minus X. VL lab, N minus 1. Vector VL at N. Well, C is 0. Lab I is negative 1. VL CT, well, lab I is negative 1. CT dot pushback I. Lab I is C. I equals AI. At C is CT. VL lock N. Seg tree max T ST. For I is 0, I is less than I plus plus. Lab I is greater than last. Find first. 0, 0, M minus 1 I. V is min V I minus 1. Swap V lock I. So if label I is greater than last, then that means that I has not been hit yet. How are you runtime erroring? How? Eval lazy I TL TR. Right, if TL is TR, tree I dot val is greater than or equal to V, return TL, return 1E9. Eval lazy 2I plus 1 TL TR. Turn find first 2I plus 1 TL MV. M is TL plus TR over 2. What do you mean runtime error? What does that mean? What does that mean? What do you mean runtime error? Like how? Okay, I mean, okay, 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 I mean, go to the print statements. I mean, how are you runtime erroring, dude? How is that happening? Jumpo file, the sum of n does not exceed 2E5. Shuffle it up again. How? How? What is going on? You're gonna crash if I run you on a random case? No, you're fine. Actually, give me the whole output. What the hell? What? We say just a permutation refers to a permutation of 1, 2, n. I don't understand what runtime error means. What does that mean? What do you mean by that? N equals 200,000. could it be in the segment tree? Eval lazy. So start at 0, go from 0 to n minus 1, and have the thing of I. V is min, v I minus 1. Yeah. Yeah. Yes, indeed. VLAN iota. What? VL lab n negative 1. Vector VL at n. Oh. 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 Wait, that shouldn't actually be an issue. No, it shouldn't be an issue. Yeah, that's not an issue. Okay. N equals 200,000. VLAN. Lab I is negative 1. CT.pushback I. Lab I is C. I equals AI. And eventually we'll return back to I. Sort CT.begin, CT.end, at C is CT plus plus C. VL lock N. I equals 0, I is less than N, I plus plus, lock AI is I. Seg tree max T ST. For I up to N, BI is AI, ST.init NB. Could you be the lambda? Is the lambda screwing me over? Let's just get rid of you. N equals 200,000. VLAN iota A.begin A.end 0. Shuffle A.begin A.end RNG. Yeah. VL lab n negative 1 vector VL at n. Lab I is C, I equals AI. So it's a permutation, so that's not going to fail. Sort CT.begin, CT.end, at C is CT. At C is CT, plus plus C. VL lock in. Log AI is I, seg tree max TST. For I is 0 up to N, BI is AI, ST.init NB. Last is 0. Label I is greater than last. V is SC.find first 0, 0, I minus 1 I. V is min, V I minus 1. X is V, Y is I minus 1. Wait, what am I doing? No, that's not I minus 1. What am I doing? Let's lock I. Got rid of the lambda. Would that be the bug? I don't know, man. Well, let's solve this as well. Permutation P. Still, runtime error on the same test. A completely random test that makes no sense, that cannot be found. C to N, VLAN. I mean, there's no multi-test stuff going on here. Are you Stack Overflowing? I mean, no, right? No, you wouldn't be. I is 0 up to N, BI is... What the hell? C to N, VLAN. Lab N -1. I is 0 up to N if lab I is -1. For I is 0 up to N if lab I is -1, which you will be for 0. VLCT, while lab I is -1. We don't need you. We're not using you. I'm not using at. Scene to N VLAN. It's probably the segment tree, I mean, somehow. Eval lazy. ITLTR. Oh. That's why. Because of the segment tree. Isn't it? Isn't it? It's that one out of bounds that just, ugh. I need to template descent. I need to fix my templates like tonight because this is absurd. The amount of times I've screwed up descent in different ways is actually crazy. That's actually insane. All right. Jesus Christ, dude. The amount of times I've screwed up descent. Given positive integers n and k in a sequence of n positive. Yeah. MST online. So it's max, right? Okay. God damn. What a waste of time. What a waste of time, man. Let's solve C. J minus I is less than or equal to k. There's an edge between vertex I and vertex j. Okay, so which edge, what's the lowest edge? So it's max, not min. So the lowest edge is what? So I mean the arrays don't matter, right? Permutation P of 1 to n. F of P the answer. Yeah. Alright, so place you on the permutation, right? So order the values arbitrarily, right? I mean, the array values, the order of them doesn't matter. The order of the array values doesn't matter. Right, so it's max. We're looking for the minimum spanning tree. So you're going to have an edge with everything smaller than you. You're going to have an edge with everything smaller than you. So I mean, arbitrarily order the elements to break ties, right? Then we're going to run an MST algorithm. So consider the smallest, right? Then place the next smallest down. Can we do like contribution to sum? How about that? Let's do contribution to sum. So for this, you will have an edge with every element that is smaller than you, such that those guys are not k apart, right? I will have an edge with every element that's smaller than me. So 2, for example, right? I'll have an edge with every 1, except for the ones that already have an edge. So if I have no 1 in range, if I have no smaller element in range, then there's nothing to be done. If I do have a smaller element in range, if they're connected, so we can have at most 2 connected components. let's fix the distance between the two, right? Okay. C and N. BL-A-N for X, A, C, and X, or A dot begin, A dot end. We need mod op. Gen factorial n. Okay, so L answer 0 for L I equals 0. Okay, so this is the number of elements that are smaller than you. LO big is equal to LO big is n minus 1 minus I minus 1, right? So for 0, yeah, n minus 1 minus I. Well, n minus I minus 1. Yes. So what we need to do then is, there are 3 cases, technically 2. Wait, how? How? So we place U somewhere, right? We're going to place a certain number of smaller elements down, up to k on each side. We're going to place a certain number of smaller elements down, up to k on each side. Yeah, we're going to place a certain number of bigger elements down, up to k on each side, right? Okay, so for L size is 0, size plus big, size plus plus. T is equal to size plus 1. count. What are you? 5,000? 5,005. For size 0, size less than n, size plus plus. For L0, L is less than equal to size, L plus plus. LR is size minus L. You we don't care about. I'll count 5,005, 2. For LS is equal to L is greater than equal to K. Plus count size S. Okay, so all left. All F is equal to NCK big size times fact size mod. So choose an order. Yes. NCK big size. R is F times NCK I times I mod. Then R is R times NCK I minus 1 rem is big minus size. Plus R times so your count size 1 plus count 0 plus count size 2 mod. Do the same thing here. Zero. This should actually be the exact same. If I is greater than equal to 2, R is equal to F times NCK I2 mod. R times NCK I minus 2 plus rem mod. Rem mod. Count size 0 times 2 plus count size 1 plus count size 2 mod. Okay, no way this works first try, but worth a shot. Yeah. Okay, that's not expected. What?
Why? Oh, because I don't. 1140. Do you work on the n equals 2 case? Yeah. Why 1140? So 3, 2, 1, 2, 3. So for all permutations, it'll be 5. Yeah. For all permutations, you'll be 9. 216. Okay, good. Why? Size equals 3. Count size is 2, 1, 1, 0. Okay, for size is 0, size less than or equal to big, size plus plus. And CKIL times 2. Are you overcounting now? No. Wait, what? How are you overcounting now? R is equal to R times, what are you? So, I minus 2 plus rem plus 1 mod mod, right? Are you gonna be worse? Okay. 3, 2, 1, 2, 3. Okay. Okay, size is 1, size is 0, size is 1. Okay, so y? PRISM. PRI size SM. So I is 1, size is 0. SM is 2. So for size being 0, right? Size being 0, that means we're putting U to the left. Or to the right. For size is 1. That means we're putting U. Yeah, so for I equals 2, means both of you are smaller. So we can put you both to the left, put you both to the right. Oh, 1 plus size. What are you? So size. So if k is 2, plus 1. If k is 2, we need at least 2 elements. Okay. Beautiful. To be correct. Okay, lovely. Good. C into n to k, VLAN, yeah. I is 1, I is less than n, I plus plus, yeah. You're all modded. You're all modded, you're all modded, you're all modded, you're all modded, you're all modded. You're all modded. All of you are modded. Yes. Okay. Alright, now we need to see what the hell is going on with this problem, right? How much time do we have left? We have 17 minutes. Okay, we can save this. This can be saved. In theory. What is going on here, man? What is going on? Okay, look. So we have this code. So c into x to y, gem prime is 1.26. VLF is factors x, map LLV for LLXF plus plus VX. VLT for each distinct thing, t dot pushback c, sort t dot begin, t dot end. LR is t dot back. T dot pop back. LP is 1 for each c and t. S is y mod mod times c plus 1 mod mod. Y mod mod times c plus 1 mod mod. P is p times s mod mod. So yc plus 1 mod mod. Or is it, wait. Is it yc plus 1 or y? Wait up. If you're to the 4th, right? Yeah, yc plus 1, yes. Yc plus 1 mod mod. P is p times s mod mod. Right? If you have 2 factors, if you're 2 to the 2, raising it to the 2 makes you 2 to the 4. So it's 2 to the 2 times 2 plus 1. Those are our options. Then we have yc, y mod mod, I mean, that should not be the issue. It should not be the issue, but I have no idea. R is t dot back, t dot pop back, right? P is equal to p times k mod mod. Yc plus 1 times yc. Y mod mod times r mod mod. C into x to y. P is p times k mod mod. P is p times m inv r mod mod. P is p times k mod mod. P is p times m inv r mod mod. Right? It's like we have large cases here. Actually, let's just, right? Shuffle. Should be the same answer, right? Okay, I mean, why mod? I mean, you pass half of the cases. How many times can the product? Oh my god, it's floored. It's floored. It's floored. Okay, I see. Yes. LF BLT LO R. Okay. F TR mod. Okay, right. So P is 1 for LCT. Yeah, you're fine. You're fine. YC times R. LB is equal to FTR R. Return P. Huh? No match for call to VL. Oh, I see. Stop. Does that actually matter? It would, right? A minus B plus mod. That would matter, right? Would that fix it? Damn. Does that make it more wrong or less wrong? Same amount of wrong. Why is it same amount of wrong? Okay, wait, so you are floored. Which means that this could be an issue. LP is 1 for LLCT. So LOP is 1 for LLCT.
right? Wait, no, floors don't. Yeah, yes, they do. Do they? Yes, they do. Right? No, wait, do they? No, they wouldn't, would they? Would it? C index to Y. While V mod X equal to 0. Oh. That's wrong. So I didn't fix it because of something. Yeah, that's not correct. Okay. Int 128t stupid is equal to y times r plus 1. S2 is equal to y times r. If stupid mod 2 is equal to 0, stupid. Okay. There we go. Okay, this is wrong, but this is completely wrong, but I don't care. Okay, good. Where'd the problem go? Yeah, so you can't do that. You can't do that. God damn it, man. You can't freaking do that. Not allowed to do that. So I don't know modular arithmetic. Still? I don't know modular arithmetic, apparently. You're wrong less? You're wrong less. Wait up. Wait, what? LLFF, VLT, LLR, LLmod. LLP is 1 for LLCT. LLS is Y mod mod. Times C plus 1 mod mod. P is P times S. Mod mod. What the hell? LP is 1 for LCT, LS is y mod mod times c plus 1 mod mod. P is p times s mod mod. Int 128, t stupid is yr plus 1. S2 is y times r. Oh, that overflows. Okay, are you gonna work? Are you gonna work? Okay, come on. I have faith. Oh my god, that was so dumb. That was so dumb, dude. Oh, that was so dumb. What is this? What is a good triangle of area S over 2? That's good. Contains exactly 1 square of area 1. That looks fun. I don't want to do that. Yeah, maybe not. Maybe not. Maybe we don't do that one. Sure, that looks fun. Okay, well, that was horrible. And we are likely doing terrible. Yeah. Actually, it wasn't. We ended up around the same, somehow. Given all that, we ended up around the same. Literally the same, literally doing the same each day. I don't understand. Okay, so I mean, like, where would we have ended up without B? Oh, we had 1700, yeah. Okay, so it wouldn't have changed our rank. I mean, okay, so like, I don't know how to do modular arithmetic on B. That's the issue. I don't understand what floor means. I don't understand how to do modular arithmetic at all. You can't freaking divide by 2 like that. That's why did I think that? I don't know why I thought that. Why did I think that? I don't know like why I thought that was a thing you could do. I'm very confused by that whole thing, but I don't understand. Okay. Well, that was fun. Yes. Okay. Yeah, I'm sure there's a cleaner way to do D without like descent, but whatever, this is fine. C was clean. That was fine. I'm okay with how that problem went. D was okay, except for the fact that we screwed up descent. I need to template descent. I need to do it. Straight up, like, that is... The amount of times I've screwed up descent is absurd. Like, I've never made that bug before, but I wouldn't have made that bug if I just had a template for descent. I had a DSU template bug too. It wasn't even a template bug. It was a bug from bad templates. Yeah. Explain what I did to fix B? Sure. Yeah, so... Tom, good job. So I don't know how to do modular arithmetic, clearly. Like I mean, fundamentally, like... Fundamentally, like, you want to take, for example, the largest divisor, and... Like, the point is to fixate on a single divisor. So let's pick a single divisor and count how many times p to the k... If a has power p to the k, then we just need to count how many times p to the k shows up in the divisors of a to the b, which is just counting the power and then floor dividing it by k. The problem is a floor, which means what you need to do is you need to subtract out the remainder before you actually do the division. So what this does is, this r is the factor. So I compute the count mod the modulo, and then I also compute the count mod the factor, and then subtract out the count mod the factor, and only then divide by r. Also, you cannot divide by 2 like that. After. You can't divide after modding. Like, it just doesn't work that way. Like 10 to the 9 plus 8 mod and then divided by 2 is not the same. Actually, it is the same. Wait. No, there's something that's not the same. There's something that's not the same. I don't remember what it is, but there's some example that's like not the same, right? Is it 10 to the 9 plus 10? Wait, okay, hang on. Let me do some testing. There's something that doesn't work, and I don't remember. I'm very confused. I don't have an AdCoder rating goal. I seem to be in the 2600s like consistently, which is very strange, but apparently that's my rating. I don't have a goal. Like, I don't have expectations, but I seem to be consistently in this spot for the past 3 contests, so whatever. I mean, this one we screwed up so much and we still ended up in the same area. These end up the same, right? Yeah. There's something that doesn't work. Oh yeah, it's with non-prime modulos. With non-prime that wouldn't work probably. Yeah. Yeah, with non-prime that wouldn't work. Because it's prime, that's fine, I guess. Yeah. Okay. Sure. Noted. Yeah, because I remember that was fine, but okay, yeah. Yeah, because that's how that works. I mean, you're allowed to do that. Okay, well, that was the contest. Let's add in the... Let's add in the things. What are you, 2593? Around 94, damn. 2633, yeah. So like pretty much the same throughout. Apparently we're not red, which is a shame, but hopefully we'll get better, I suppose. We'll see with that. Yeah, okay, so that was in the past. Now, do we do this problem again? I don't really want to do this problem again. I don't feel confident with the solution. Okay. This we looked at, yeah. Have we seen this? We've not seen this. Okay. This one, tractor. Great. And of course it was this one, right? Are these good? Okay, we can try F. Maybe G. Well, that looks pretty hard actually. But we'll try them both. Solve one of them. Okay. Cool. 14. I'm sorry. Okay. Anything else about that contest, by the way? Or I'll move on. I'm sorry, what? You can choose where you spawn. So you either spawn on a quest or a tower, right? I don't understand. Time. That's the state. That's confusing. Right? Yeah, that's the state. So we need to read G. That's what we need to do. Okay. It's a flat in central London. You said to rent his flat out for the next 10 days. Someone wants to book the flat from day LI to until RI. Okay.
Yeah, so okay. Cool. Cool. So the number of acceptances is small, which means if we can simulate smart, we can simulate. How do you simulate smart? So 5E4, which means constraints are low. Okay. Start with 1. Keep track of what is taken. What is it from? Oh yeah, okay. H has no souls, of course. Yeah. So like these two problems together are 3100. It's a strange phenomenon. So I should be able to solve at least one of them at the same time. F looks more promising. Just feels better. So I mean, the only semblance of time we have is quests. So the only state we can have, thus, is quest and being on, like, completing the ith quest. So we need to do some efficient. Why is the sample like this, man?
This is gonna be painful. This problem feels like the doable one though. G seems, I don't know, weird. And we'll either go to another quest or unlock a tower. Does it take a time? It doesn't matter, but. Yeah. I don't know what this idea is, but it doesn't really seem like an idea problem. I'm gonna try G2. Yeah, okay, so. Okay, so 3 to the 14 times 14 cubed. I see the issue. Yeah. Actually, oh, no, it doesn't matter. Problem is going to be time, of course, but we're going to have some fun with the constant in this problem. So actually we don't need the ending state at all. Fast travel do be like that. So the state is, given that you have these towers unlocked and you're at a tower, for each submask of the locked set, find the min time it would take to unlock that submask. Then the state is current quest and the state is current quest or tower. This doesn't seem that bad. It might be tripping. This doesn't seem like it'd be the worst. So at this quest, we can task, of course. Never going to remember that. I didn't even do the act coding one. Just completely forgot to do that. Nice. Yeah, so the state is current quest and tower. You can add an auxiliary quest for each tower. Sure. Then, from this state, we can go to another quest. Now, we will capture a possibly empty subset of towers. No, we'll either go directly to another quest, or capture a possibly empty subset of towers. And then from there, go to another quest. We can make the quest part of the state. Should we just do that? Or we can make the time, what's the better way to do it? And we can say min time to have this many quests completed. Should we just do that? That might be better. Min time, well, but then I don't know, man. It's the constant. It's the constant. It's about the constant. But then, like, but then what? Then we'll spend 100 times 3 to the 14th times 100. 3 to the 14th is already big, so that's not going to work. Might have to put the quest in the state. But can we even do that? Because then our state is location, number of quests, and mask of towers. Which is already a lot. Location, number of quests, mask of towers. And that's the min time. We only need to transition out of relevant states then, which is useful. How much memory? 2 to the 14th. Yeah, that's big. That's big. We can save memory, but well, not really, right? Min time. Guess the problem here is the constraints. That's fun. So we need to do this in a way that doesn't take, how much is it? 10 billion operations? That's probably too many. Probably. Very probably. I'll get more water. So, thing. What about the thing? What about the thing? What is with the thing? So, maybe we can chain quests. No, but yeah, that doesn't. Does that work? Wait. Well, no, but then. Yeah, and then stuff. So we can go to a tower. So from a quest, we can go to another quest. Or go to a tower. Oh, but what's the point of min time? What's the point of min time? If we have min time, because if we don't have min time, we can shove something else into the value. If we don't have min time, what do we have? What do we have? Do I have something else? Okay, yeah. Yeah. So stuff in this problem is happening. I don't know what is happening, but stuff is. We need a better formulation. Something that doesn't take 20 billion ups. If we can cut out a factor of 100, that'd be fine. The next n lines contains two integers, xai, yai. Yeah. So if we could get min time out of the way. Right, so for a quest, we don't need min time. The only time we need, okay, wait, can we like make something happen with the, so I mean, given a particular mask, we can easily compute the cost to extend it. The problem is that iterating over submasks is going to be an issue. So maybe towers and quests are a different state entirely. Like maybe we have dp tower. So maybe we have dp of tower position, mask of towers, number of quests equals min time. And then we have dp of quest, quest mask of towers, and equals, yeah. Can we do that? As long as we're careful, right? That's the thing, as long as we're careful about it. The thing is, we need to order the iteration, right? We need to order the iteration. How do we order the iteration? How? How does one order the iteration? How does one order the iteration? If you order the iteration, we have a log on our hands, which is not good. But do we? Do we, though? Probably, right? Okay. We process a quest at a time. Then we have... Yeah, we process quests in order of time. Sure. Breaking ties arbitrarily. Given that locations... Well, breaking ties arbitrarily. Alright. Then... Well, we need to not go through all of the other states per quest, right? Yeah. So we need to like not go through all of the quests. Well, they're gonna be hopefully monotonic per time, right? Hopefully. This is absurd. This is, wait. This is absurd. No, this is just as bad. Okay, yeah. So this is a complexity problem. Supposing we do this, the first dimension is fine. So you, and you are okay. So we have state, quest, and mask. Storing number of quests. That's okay. That's like 1 million. And we have state, tower. No, wait, no. Oh, we don't need the tower we're at. Okay, so mask of towers. So mask of towers, number of quests equals min time. Somehow we combine these two together, right? Mask of towers, number of quests equals min time. So per quest, we can actually go through all of these. Now that this exists, now that this is a thing, we can actually go through all of these. Can we really like do that though? So every quest, we go through the towers and update them. So every quest, right? So the move is we can either go to a tower. Will this pass? 14, man, 14. It's gonna be 100 squared times 2 to the 14 times 14, which is better than before, but that's still pretty bad. It's like this transition out is fine. The problem is, oh, wait. We might be fine. This might be fine. This is maybe fine. Should we think harder? We could think harder. This is maybe fine. The problem is it's gonna be painful. I don't know, man. God, per quest, we iterate through the masks. We can go to another tower. We can pre-compute all the costs for that. That's okay. I think this is gonna work. I have some faith. I have a little bit of faith. Okay, so I have like the smallest amount of faith, which is, I guess, the best we can do, right? Okay, so int dpq 1 of 5. So quest mask we're gonna, yeah, no, this is fine. To the 14. Then we do mask cn okay, so No. Yeah, let's just VQI1 Okay, now for L equals 0 plus plus dpt VQ 2 to the I 0 equals 0. Yeah, okay, sure. Good. dpt 2 to the I 0 is 0. For L equals 0, I is less than M, I plus plus dpt, wait, this is dpq, now it's dpt tower. I need you to be here. So dp quest 1, no, dp quest I 0 is equal to 1. Okay, now for L equals 0, I is less than M, I plus plus. Go into this quest. Okay, so for hello R0, R is less than N, R plus plus. You're 2 to the N. So for each mask of things, actually, you're going to be this because this makes sense. Okay, so NQ is 0, NQ is less than equal to M, NQ plus plus. For hello, MK is 0, MK is less than 2 to the N, MK plus plus. For LO, NV is 0, NV is less than 14, NV plus plus. If MK, if this is not set, then go from MK. Okay, so int MD MD is equal to min MD dist LT. If I shift K and 1, LTJ, LTK. MD IJ is equal to MB. So then take this tower. I screwed up. God damn it. This is fine. Why did I delete it? Don't do that. So dpt nq mk 2 to the nv equals min dpt nq mk dpt nq mk plus md mk nv. Okay. So we transition out, then int mdq j is 0, j is an m, j plus plus, mv is 289, k equals 0, k is less than n, k plus plus, if I and k and 1, mv is min, mv dist, vq j1, vq j2, ltk. mv is min, mv dist, vq j1, vq j2, ltk. md mdq ij is equal to mb. Okay, this is all fine complexity wise. If dpt nq mk is less than or equal to plus mdq mk I is less than or equal to this distance, which is vq I0 dpq imk is max dpq imk nq plus 1. Int. Sure. We're gonna make you all ints anyway. Let's just, yeah. We'll do this in constant opt. Okay, right. Let's do it now. Okay, we're going to remember to fix this before we do the next problem, please. Okay, now go out of this quest. For int mk is 0, mk is less 2 to the n, mk plus plus. Go into tower. So we can go directly into a tower. so DPQ. DPT. MK. NQ is equal to DPQ. DP what? DPQ I. Okay. NQ is equal to min VQ I0. NQ greater than or equal to 0, so we can reach the state at all. Which we should be able to. No. Yes. Absolutely we can. Oh, no. Okay. So we can go into a tower. Conquer new tower. So for int I j equals 0, j equals n, j plus plus, if not mk shift j and 1, dpt, wait, shoot, nq, mk, nq, mk, I'm going to screw this up a lot, huh? nq, mk, min dpt nq, vq I0 plus dist pl cur vq j1 vq j I2 dist lock. I need to lt j. For int j equals I plus 1, j equals n, j plus plus. If so it's vq I0 plus dist pln lock is equal to vq j1 vq j2 lock n lock is less than or equal to vq j0 dpq nq plus 1 mk is equal to max dpq nq plus 1 mk. Wait, what are you? No, what are you? You're j. J nq plus 1. Okay, I'll answer 0. For all mk equals 0, mk is less than 2 to the n. dpq I mk. Okay, no way this works. No way this even compiles. It compiles. Does not work. How are you 6? Okay, that's... should not be 6. Okay, we're gonna have to read this code. Scene to end to m. For I up to n, read into LTI. For I up to m, read into VQ. Then sort the quests by time, arbitrarily. Memset dpt, memset dpq. initial states say that we can reach this at time 0. We can reach this with 1 quest. So for I equals 0 up to 2 to the n, for j is n, I shift k and 1. So this is the distance from I to j. And similarly, this is the distance from I to quest j. So first of all, do these transitions. dpq. So for this number of quests, for this mask, for this thing, if not mk and nv, so if this mask, if this is not set, you are a minimum of u, and the time to get to that tower plus the minimum distance from the mask to this tower. Yeah. Okay. Good. That shouldn't actually. Okay, whatever. dpt nq mk. I mean, yeah, you're gonna overflow, but how does the answer become more than n? Oh, that's how. Okay, I see. Yes. No, that doesn't make any sense. No, it makes a little bit of sense. Okay, yeah, sure. PL log is VQ I1, VQ I2. So for MK is 0, MK is up to 2 to the n. Do this quest. So if this state is reachable, go into the tower. So just go into the tower. DPT NQ MK. Yeah. Conquer a new tower. So if this is not conquered, conquer needs. This doesn't take any complexity, so that's fine. This time plus the distance, and go to new quest. So if this is fine, this is fine. Yes, then yes. Okay. So now we test the constant factor. As soon as you load, thank you very much, Codeforces. Good. Okay, so 14100 LTI0 is equal to RNG mod. VQI1 okay, cool. How long do you take? Why do you not compile? .f .s. Yes. How fast are you? Holy Christ. Okay. Okay. All right, we got some work to do. Let's get rid of this. This should make life easier. I mean, this loop is the main complexity, right? Yeah, but it changes the answer. Why does it change the answer? Invocation failed. The hell? Okay, that's Codeforces. Alright. So it's barely faster. Sure, okay. Let's try the other versions. Oh, okay, that was a bad idea. Try this. We'll put in the pragmas after. Okay, that's slower. It's always slower to do 17. I'm not sure why. Like, we don't need that if. It makes it slightly faster. Okay. I mean, this is the complexity right here. This one loop. Wait. Yeah, okay. That should actually work. Beautiful. Why do you not work on my computer? That's like really annoying. Okay, you're gonna get wrong answer, but you're going to pass the time limit, which is good. You're going to get wrong answer probably, right? That's probably what's gonna happen. Wrong answer in test 2. Great. Okay. So we debug. Soon to end M. Sure, yeah. So you're up to 10 to the 6, which means that you're not going to cost anything. So DPT is huge, right? Yeah. So the initial states are, we can start at any quest. The initial states are, we can start at any quest. We can start at any tower. And say that that tower is conquered. Okay. Say that conquers tower. That conquers towered in 0 time. Or we can start at any quest and say this quest is done. And therefore we have 1 quest. Now, for each mask, are you a big test? You're not even a big test, are you? Yeah, small test. Yeah. For each set of towers, for each possible tower to go to, actually, no. I mean, that shouldn't be necessary, right?
I mean, the cost to go from this set of towers to this new one is 1E7, but we could have instead just spawned in at this tower, or gone to this tower. That might actually be it. Let's fix that and then do something else, right? So this is for each quest. Yeah. For I is 0 up to n. NQ is 0, NK is up to I. NQ plus plus. For each mask, for each thing. So DP tower is min DP tower. And DP tower this plus min dist. If dpt nqmk plus mdq mki is less than or equal to vqi0, dpq jmk is max dpq jmk nq plus 1. dpq imk nq plus 1. Yeah. dq mki. PL lock is VQI1, VQI2. NQ is greater than or equal to 0. NQMK is min dpt NQMK. VQI0. If not MK and J, L1, dpt NQ, VQI0 plus dist lock that tower. Or go to a new quest. That should be M. J equals I plus 1 J, so then MJ plus plus. Via N lock. VQI0 plus that distance is less than or equal to VQJ0. dpqjmk is max dpqjmk nq plus 1. Yeah. Okay, any other such bugs? You're up to M, you're up to N, you're up to N, you're up to M. Sure. That was dumb. Great. Okay. I don't know. What's up with that? 0, 4. God damn it. Okay. What do we have to do this? Do we have to run through our code again?
equals 0, I up to n. Plus, I can start at this tower for free with no quests. Can start at this tower for free, or we can start at this quest for free. And there's nothing else we would need to do. And v is only 7. It's up to I, right? It's up to and including I. 0 quests so far. Then we can join this quest. Alright, I0 up to m, I++. NQ0 up to I inclusive. Mask is 1. NQ. So I mean, if NV is already part of this, then this is literally useless. It's a useless thing, but it's faster to not have that if. So this is fine. If dpt plus ndq. So if we can go from there to this quest, then let's go from there to this quest. Unlock is VQI1, VQI2. For each mask, I can do dpqi this mask. NQ is greater than or equal to 0. Should be 1. Let's try some logic. So 1, 1, 0, 0, 1, 0, 100, 105. So you can't get all 3, right? Should not be able to get all 3. Then we make this 1 later. Should be able to get all 3. Yeah. Okay. Guarantee that all locations in a quest are different. So So you have to be on that item, yeah. Should be able to get off 4. Yeah. I can make you bigger. Shouldn't matter, but it might, if it shouldn't. But it might, but it shouldn't. But it shouldn't. It might, but it shouldn't. Ugh. Is there overflow anywhere? (2e8). Dist is small. Dist is up to 26. So DPT can be huge, but it's like OX6F, which is fine. Because MD is 2e8. DPQ IMK is max, yeah. DPT plus MDQ. MDQ is always going to be small enough. VQ plus dist. Yeah, that's going to be fine. That's going to be fine. That's going to be fine. J 0 up to N. Q is DPQ IMK. That's like 5, 5. See if this, something like this is weird. No. 0 I is an M, I plus plus. For mask is 0 up to 2 to the N, I plus plus. This is max and DPQ IMK. Yeah, so it seems right. Need to question every part, right? So read into N and M. I 0 up to N. Read into the locations. for you, read into here. If there's a tie, it does not matter. Because all locations in a test are different. There's a tie, we cannot possibly satisfy both quests at the same time. Therefore, we don't bother trying. So we sort BQ. By time. That's fine, yeah. Okay, so for this quest, so our options are to go into this quest from the tower states. So what we need to do is propagate the tower states, right? So we propagate the tower states. And then we literally go through each tower state. And for each tower state, if we can go from the towers to this quest in time, then try it. We can go from the tower state to this quest in time, then try to do so. DPT is max, DPQ, and Q plus 1. Yeah. Then PL lock is VQI1, VQI2. Then we can go out of this quest. So if this state is even reachable, go into a tower. So from this quest, we can warp to a tower, can conquer a new tower. We can warp to a tower. We can warp to a tower. Just warp to a tower directly. Or we can go from this position to a new quest. Or we can go from this position to a new tower. BQ I0 plus dist. This wouldn't overflow, right? No, because you can't get bigger than the, yeah. This is min, not max. Dist lock LTJ. I+1 to a new quest we go. So if this plus this distance, it's Manhattan, right? Yes. That would be a good thing to know. If it's Manhattan or not. It is indeed Manhattan. Still. Turn 11, move to 6-2. I equals 0. MK equals 1. I can do MK equals 1. And go to that quest. Then hit that tower on the way. Let's reread this statement. William is done with work for the day, enjoys playing his favorite video game. Yeah. Turn 0. Pick any cell in the game world and spawn in it. Each turn, he may remain at his current location or move from the current location to any of the horizontally adjacent cells. Accelerate movement, the game has end fast travel towers. I tower is located at location X, A, I, Y, R. Activation of tower I happens in the moment when the player is in cell. Yes. The game has M quests. quest can be completed instantly by being at location XBI, YBI on turn TI. Should be 3 then. Yeah. It's a 0. Let's check dumb things. It's probably a dumb thing, right? MDQ, mask I, DPT, yeah. It's NQ, 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 mask NV. PL lock, MK0 up to 2 to the n into NQ, DPQ I MK. NQ is greater than or equal to 0. Not MK shift J and 1. DPT NQ MK or 2 to the J. You know, it's not allowed, but whatever. Okay, let's try to stress. I'm confused. Wait. This assumes things aren't the same, which is true. Okay, why? Oh, that's why. How are you 7? How are you possibly 7? So you're 1. Oh, no. No, if nq is not equal to q. Right. That's what's happening? Okay. Damn. Why? So at 4, you have this. So we want to spawn on 5-2. Just the third tower. 3, 4. D is less than or equal to VQ and Q0. DP0 MKT. I'm sorry, what? Oh, it's because of stupidity. Yes. So T is 0 up to MT. For MK is 0 up to 2 to the n. For each new tower. If you're not already there, for each tower, go from that tower to this tower. If you're at most of the time, DP0, D is max, that, DP0, MKT. Yes. Or we can go to a new quest. Yeah. So for each quest up to M, lock. For each mask up to N. Oh, that's why. Still. Really? Really? Okay, that's better. No, it's because of this. Damn it. Okay, let me take out the useless tower, right? I'm not using 2, 3. I'm not doing this quest. I'm not using 1, 1. Oh, copy the whole file, yeah. Okay, we're not using 1, 1. So what the hell is going on? So we start at 5, 2, right? Then we have this mask. Then we're at this quest with this mask at time this. Then at time 10, oh. So should we do this twice? Let's do this twice. I was thinking that, but I wasn't sure. I thought it wouldn't matter, but I guess it might. No. Okay. Okay. Alright, good. No, we don't PRDP. What? Why? No, this shouldn't change this at all. Yeah. Why would I think it would do that? Why use 6? I mean, no, this shouldn't change anything, should it? Shouldn't have to change this. No, it does. It does. No, it shouldn't. We'd want to do tower. We'd want to do quest, then tower. Okay. Are you serious? Okay, well, I'm gonna make you smaller anyway. Okay. So we get all the towers. Then 8, 6. Okay, so which one does that say we can't get? 5, 10, 7, 5, 3, 1, 8, 3, 4, 2, 8, 7, 6, 7, 32. I should make the program do this next time. Whatever though. multitests. Wait. What? Okay. So where do we think we can't reach you? No, we can definitely reach you. So answer's wrong. Yeah. Okay, good. So PRIMK DPQIMK. We finally have a case. So bit set 5. Okay, so alright, this makes sense. Wait, I thought Bitso was backwards. Okay, whatever. Good. Damn. Why though? Why though? Like, how? How? Wait, what? Wait, there are 2 at 79? Oh. I didn't even realize that. Okay. Wait, how the hell? Wait, then why do we think... Why? Why? Just why? Why, man, why? There are 2 at 79. VQ and Q1, VQ and Q2. D is less than or equal to VQ and Q0. D is less than or equal to VQ and Q0. We're gonna have to do it. We're gonna have to frickin' do it. So we're gonna have 10s here. Okay, fine. Wait, why did I do it there? So 4, 4, X, PRI, you have 8. Then you have 10 somehow. Where's 0? How do you have 9? How do you have 9? Oh. That's why. That's why. Quest. Wait, no, wait, this still doesn't make much sense. How do you have 9? Quest can jump the tower. Alright, but how can tower jump back to quest? Dist LTR. VQ NQ0. And the tower is not on that, right? Wait, it is. Wait, why? Oh my god. That's why. Okay, so the freaking case is invalid. Okay, stop. Great. Okay, so I have a bug in my stress then? Is that what's happening? I have a bug in my, just everything. Game happens in 2D world starting at turn 0. William can pick any cell in the game world and spawn in it. Then each turn he may remain in his current location and move from the current location XY. Isn't off by 1 somewhere? Okay, well, cool. 20. Okay, good. See out and 4 L equals 0 as an N plus plus see out. God, how many freaking times am I gonna type that? What now? As soon as M exceeds 14. I'm I'm sad. I'm sad. I'm so sad. I'm so sad, man. I'm so sad. Okay, fine. Why? Let's get rid of all this. Oh yeah, this could actually like, yeah, yeah, that will actually not run. I'm so sad, man. I'm so sad. Okay. Well, what's up with that? I'm so sad. I'm so sad. I'm so sad right now. I'm so sad. Oh my god. And that wrong answers instead of runtime error, because why not? Check everything, man. Check everything. Stop. Oh wait, I commented out the pragma. That's why, isn't it? Wait, why are you so close all of a sudden? Wait, what? Wait, what happened? You're fine. Why are you suddenly not fine? Let's make it faster. Not really. Oh. Yeah. Okay. Okay, let's flip the dimensions. JI. Wait. Okay, we definitely want to keep you as is. But we probably, actually, then none of this matters. Right. I'm gonna change the answer. That makes you slower. Okay, cool. Did he make you faster? Okay. I don't know why that makes you so much slower, but whatever. But that actually makes no sense. Submit this again. All right. God, man, I'm so sad. I'm glad we made that bug in practice. I'm so glad. I'm so glad we made that bug in practice and not anywhere else. Okay. I guess that pragma helped, huh? Nice. Stupid. Very stupid. Cool. 3,300. That really should not have taken so long. But it did. And we spent an hour. An hour debugging that this should be 100. This should be size 100. That's what we spent an hour on. Oh, God, dude. If not for that, this would have been so much less painful. That was like that and the, what was it? This should be M. That was like the only bug, right? Yeah, that should be M. And the loop should maybe start from 1. And that's it. That's the only bug. And then we're going to get TLE, and then we're going to spend a few minutes constant optimizing, and then we'll be fine. That is it. That's all that should have happened. But no. It just had to be painful, man. It just had to be so painful. Do we try G? I don't really want to. What solves does G have? Has fewer solves. Yeah. 3,500. Probably be 3,400, I guess. Yeah. Okay, screw it. We don't need to do it. Let's do a div 2. Let's finish off with that. Actually, no, we can do one more hard problem, right? Which one was this? I don't want to do that one. That one seems like math bash. Yeah, we can solve this one. Yeah, sure. No, we can't, right? Yeah, no, maybe not. Not a good idea. That is very easily 3,500. These are what, 3,000? Yeah, but it's expected value. I'm dodging it, but it's for a good reason. Which one was this? Just going back on the contest now. Oh yeah, this one. Yeah, we could try it. I remember this problem. Gustav is the chief bank manager in a huge bank. He has unlimited access to the database system. In a few clicks, he can move any amount of money from the bank's reserves to his own private account. However, the bank uses some fancy AI fraud detection system that makes stealing more difficult. Notice that the anti-fraud system just detects any operation. Was fired and taken to the police. This detects any operation that exceeds some fixed limit M euros, and these operations are checked manually. Hmm. 105 questions. Wait, what? For each test case, when you know the exact value of M, print a single line. Okay, yeah. So, I mean, this is very easy to, test. 105 operations. So, I mean, we're going to try some frontier strategy, right? Where we keep an interval, right? 105. That's really weird. 105. I'm gonna be right back. So we do this M thingy. Alright, we need it to be pretty optimized. So I mean, we can log 2, 10 to the 14. You could do it in 4 log m queries, right? .105 is really like that seems like it's gonna be tight. You know, like 105, man. That's a number. That's quite a specific number, in fact. It seems fun. Seems very fun. Okay, so we'll query. So let's I don't know, see how close we can get with some parameter screwing around. So if local, else cout if s equal to lucky bow is equal to 1. plus is equal to lucky, bow plus equals x, return 1, else if s equal to fraudster, bow minus equals x, return 0, else crash. So I mean, this should never happen, but supposing it does. Assert x is less than or equal to bow. Yeah. Okay, so let's make sure that's correct. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. L is equal to 0, R is equal to max. While L is less than R, const LD dom is equal to 1.5. Bow over F plus 0.1. If bet if rat let's make sure this actually works. Ah, stupid frickin'. Okay. 100. Sure. Okay, so 1e14. Ints, yep. Frickin'. Okay, 1.35. Okay, so this doesn't work, but it might, given an adjustment of the strategy. Max bow. No, wait. Okay, we need average. What? Wait, no, yes. Could we do this at the very end? Wait. You're getting slightly closer. Oh, that's wrong. Should be geometric mean. What are you? So you're L times pow R over L. 0.5 G5. Trace trap. What? Okay. That's better. No. Okay. Damn. What? What the hell is going on here? Oh, okay, yeah, sure. Wait, no, wait, what? Yeah, no, that's fine. So we'd rather you be higher, wouldn't we? No. Wait. With this adjusted strategy, right? We want to climb as high as possible. Wait, what is going on? It's weirdly bugged. That's way too many. Interesting. So I mean, the average is under 105, but the max is definitely not. What's the worst case? Just some number. Just some number, I don't know. Okay, so we have two phases. While L is less than R. Bet. Why? Why is bow 0? Oh wait. If bat is greater than okay, so if bow is less than or equal to L, query L. Um,
This is peak. This is peak. Might as well, right? Yeah, might as well. This could work. This could work. This could work. This could actually work. This could work. This is how you solve interactive problems. This is how you solve interactive problems, man. So we're gonna assume there are 100 tests. $108. Damn. 2.75, right? 110. So we adjust this parameter until it passes. Yeah. Okay, so 2.5 seems optimal for this. Yeah. 107. Okay, 108. Yeah, so with some variance, right? Here we are. Wait, why don't we... Bounds less than or equal to m. Query m. Query L. Oh, wait, bet. Why? One. Damn. Okay. Yes. So we need just a little bit more optimization, right? Just a little bit. Can we tune this parameter, right? So we want you to be smaller. Yeah. 2.6. $96.83. Okay, so the average here is better. 96.35. Damn. 2.5 is really the best, huh? Okay, 2.5 it is, sure. So given that,
same. Bell. Yeah, pretty much same. Okay, so this is not working. What is working? Well, L is less than R. I need just a slightly better strategy, man. Just a slightly better strategy. Really? Okay. Oh, wait. Damn. It's just a bit too much, man. It's just a bit too much. No, wait, that's, yeah. Okay, well, that doesn't help. Hoping for variance in the thing doesn't help. Two 2.5. So, I mean, my eyes are probably used to it by this point, I would say, given what I've done to them over the years. It doesn't really bother me anymore. That or I'm just permanently damaging them, but one or the other. Probably both. Definitely both. Definitely both, yeah. There's definitely damage. Did the email come out? This is so annoying. 105, man. 105. 105. I have 108. 110. 110 is a safe estimate. If the bound were 110, I would probably pass the problem. But nope. Um, wait. Damn. Make you stronger? No. Oh, that's better. Damn, that's slightly better. That's better by 0.4. Are you kidding me? 0.4, dude. That's so dumb. My god, okay. And if we test on random tests, we're gonna fail. Yeah, I mean, okay. Yeah, I don't know what I did. It just like never really bothered me to stare at a screen all day. I don't know. It's not a good thing, but whatever. It's life is short. God, 107. 107, dude. So the more we have, the riskier we should bet. You're power 2, right? Yeah. Um, nope. That's slightly better. Um, how many times do I have to do this on average? So you do it once at the beginning. But you never hit 2 again, right? Yeah, as we get luckier. One is 7, man. 1 is 7. Okay, we need just a little bit more. Just a little bit more. Just a tiny bit more. Wait, are you better? 15 is the best? Okay. All bet is n minus n plus 1. F. We're just tuning hyperparameters at this point. Are you serious? We just saved 2 queries, man. We just saved 2 freaking queries. You work for m equals 0, right? Yeah. 2 queries. Gustav has to pay X zeros from his own account as a fine. Yeah, but the probability that you're on that interval is so small that, like... No. We should have some different behavior. Wait, why? What the hell? What do you mean 160 million? What does that mean? Well, why does this not work? Why does being more aggressive here not work? Um... Stop printing. I need to freaking binary search on these parameters, dude. Wait, do you work? Damn. It's slightly better. It's better. It's slightly better. It's slightly better. Let's try being more aggressive. Did you make it worse? Yeah. 9. Damn. Yeah, okay, so if you pass a 100K test, I'm submitting it. Let's submit. No, let's not. Let's not. We can do better. We can do better. How many test cases does this problem have? That's the question, right? God, if it was just average 105. If it was like Code Jam, it was average 105. What's up, Sophie? You're still in like weird time zone, right? I need to get this number down to 105. That is my task. That is my task right now. It's very sad. It will pass 30 tests. No, it will pass, damn. Okay, that's a bad run. It will pass like 10 tests of the stuff. 2.7, right? So we need to run on 100K tests now. Okay, we don't need to print LR. That'll save us some time. Don't really need to print NQ. Let's try this. That's better. Okay, we're submitting. We're submitting. We're submitting only because it's practice. If it were a contest, I would optimize this more. But yeah, this is fine. Wait, what the hell? 3,000 milliseconds. What? Wait. You pass all the wait, I didn't actually stress test you. Did you get absurdly unlucky, or do they have strong tests? They might have strong tests. Okay, I guess they have strong tests. Damn. Yeah, that's better. Now, how big can F be? Oh, holy Christ. Okay, submitted that for sure. Okay, so I guess I just need to tune that more. Damn. Oh, shoot. Okay. That's bad. Try being crazy. Okay. Wait, did it just work? Does being aggressive with F just work? I guess, okay. Let's try it again. It works for near powers of 2 now. Damn. Okay. Stop it. Okay, that's as far as it goes. Can I make you more aggressive? Yeah, I can. Okay. Let's keep submitting. I don't know what their counter test is, but it must be strong. Hmm. Wait, so is it a query issue or a other thing? Wait, what? Wait, it's wrong answer? Wait, what? If S is lucky. Val plus equals X returns 0. So if S is fraudster. Um, oh, what? I'm very confused. What's happening? What is this wrong answer? So, if NQ No, this is a wrong answer. right? Wait, what does that mean? Why did the runtime double? Confused. We're we're not. It's not something you do in contest. I'm just under confused. Okay, so it's not a query thing. This isn't a query issue. That your program should proceed to the next test case or terminate if it is the last one. My old editor is here. I just, this is nicer, I will say. Oh, that's why. That's why, huh? I see. No? What the hell? Bro, okay. Find the exact value of m in no more than 1 of 5 operations without getting him fired. We're doing end out, right? Yeah. Bound plus equals x, return 0. Okay, I mean, yeah. What then? 1 is up to x is up to 10 to the 14th. Aha. There we go. Wait, you're bigger? Oh. Got it. Stop. Assertion failed. X is less than or equal to bound. Why? Oh, you're an idiot. You're an idiot. Okay, this is fine. Nice. Okay. Alright, well, that's it for today. Okay, that was not bad, actually. Just, except, I say not bad after all this, but okay, this was trolling. I mean, what you should do in contest is verify that it's actually the query limit being exceeded. And if not, like, try, try the limits, right? Okay, yeah, cool. You should definitely not do this in contest. This is not what I would do. Guaranteed. Yeah, okay, cool. So that actually worked, surprisingly. That was not supposed to work, but it did. How many queries does it take? It's better than the jury's. No, it's not. Okay. 100, 101, 100. Yeah, it's close. 101. Yeah, they're slightly better. I guess they have slightly better parameters. Nice. Okay, cool. Alright, well, I guess that's it. We shall leave it here. Good stuff. Good stuff today. What do we do today? We got, so this was 3200. That was yesterday. We got, this was 3200. This was 3300. This was 3200? 3300. And this was 3200. That's good. Good stuff. Hard stuff. Well, it's getting easier because we're going back in time, but still. Very nice. And what was this from? 720, 709. Okay. Yeah. Cool. Alright, well. As always. Are you serious? Okay. Good. I can get rid of this then. As always, join Discord if you want to talk or don't. Yeah. For beginners? Knowledge is not that important, so CSCS is not that important. Like, for like Codeforces, where knowledge is like very almost irrelevant, there's a very specific set of knowledge you'll need, and you can pretty much figure it out from the problems you do. I don't think CSCS is like that useful, but I don't know. To get knowledge, it's good, but like a lot of the knowledge you don't really need. Maybe the beginning of CSCS is like
fine, but ultimately, like, you need to practice problem solving, right? So that is the main priority. And with that, you would want to, practice problem solving. Yeah. And you get that from doing problems, like random problems. Codeforces. I'm out of focus. Sorry. Yeah. Ultimately, probably Codeforces is better. Just like do problems. That's the idea. Okay. If you have more questions, again, Discord, sure, and you'll get notifications too. It'll be fine. Yeah. Good. Okay. See you tomorrow. Goodbye.